Moinsen, this is Sebastian, and welcome to our live question and answer session. I have to admit that I'm already facing the first problem because I'm not really sure if you're seeing this right now or if you are still looking at a still picture of me, because there's quite a delay between the actual YouTube stream and what I'm doing here live. So no idea if you're seeing this only in a minute. When you're seeing this, you were probably just wondering why I hesitated to start talking. Welcome to the live stream. And if you're wondering, no, I'm not going to do the whole live stream through the Game Boy Color. So, yeah, here's also another camera. What you can also see is that's a different angle because I'm using the webcam from my laptop over here to stream to the Game Boy. And I'm quite happy that it holds up so long. So it's still alive? Yeah, it's still alive. Because as you probably have seen from the first video about the video cartridge, it's not the most stable contraption, although usually the stream works quite well. Is it still working? Yeah, okay. It's just the resolution isn't good enough to really see me talking over there. So what are we going to do today? I have a whole setup of things that we could stream to the Game Boy. We can look into code, we can discuss technical things, we can also discuss the background of my projects, whatever you want to ask. So the idea is that in the chat you can just ask anything if you simply enter Q followed by colon. So can I just enter an example like this? And if everything works right and the script that I just put together yesterday, I should see those questions in a separate tab because I have no idea how many people will be there. Currently it's 30 viewers. I think that's manageable. I'm not sure what would happen if more were to join, and I'm not sure if I can actually follow the chat while talking. But the idea is, if you answer a question with this Q colon thing, then I can see this in my little extra window that's grabbing these questions from the chat, and then I've got a button to show it, which hopefully does. Yeah, it does. And so I can tell you the question that I'm answering right now. Actually, it also logs it to a file, so I can do chapters later for this video. And this way, I hopefully can manage all your questions. Oh, I already see one in the chat. Please use an uppercase Q. I should have thought of that. So it has to be an uppercase Q. Okay, and just to collect a few questions. Oh, one other thing I want to do, or which I will try to do. I'm not sure how many questions will be there, but I will probably move the more technical ones a little bit to the end, because I think that there might be more viewers that enjoy both the more simple type of questions or the not so technical ones, and those who would also be able to follow the more technical ones if you really want to go into the code or want to discuss electronics. That's not for everyone. That's why I try to move them to the back. But when we run out of other questions, I will do them, and depending on what it is. Okay, so. And yeah, one thing I wanted to show before we start, so we can collect a few questions. The timing, yeah, okay. I wanted to show a few things on the Game Boy Color. Actually, it's still running. That's quite nice, but no, I have to restart it still. Because most of you, or some of you, have probably seen the demo I posted a few days ago as a YouTube short and on all the social media channels, that I actually got the Game Boy Color to work. And the problem was that I was just showing a video of Futurama. I'm saying just, I hope you all love Futurama, but I picked a video of Futurama simply because I wasn't able to grab directly from the screen and stream it through FFmpeg. So again, as most of you probably know, I'm using a Python script that uses FFmpeg to grab video from the screen or from any source and push that to the Game Boy. And I had some trouble with all the filtering I'm doing with FFmpeg to get the color palette right for the Game Boy Color. I had the problem there that it got stuck as soon as I used the screen grabber instead of an actual video file as a source. And that prevented me from showing any games, because quite a few of you asked if I could show GTA on the on the Game Boy Color 2 to compare it, and I just managed to get to find the problem with FFmpeg. So for those interested, the problem is that the screen source does not, if I understand it correctly, it doesn't have a fixed frame rate, or not. Yeah, it doesn't have a fixed frame rate. It only updates if there are changes in the screen. And with one of the filters that I used, there wasn't a default frame rate anymore. So it took the first image and repeated it over and over again. And I just had to tell it to not care about VSync so that I could get the stream out. So right now this is grabbing on my laptop from the camera that I'm playing in VLC. And so to play something in, to show you GTA on the Game Boy Color, I can just open the video stream from the PlayStation, but right now I cannot control it because I disabled the, let me switch to the other one, then I've got the microphone that's over here, so but then you cannot see me anymore. So the thing I did is I disabled the key input because I have some trouble with some ghost button presses on the Game Boy, and that really messed with all my controls if I'm not in a game. By the way, in this case, if any one of you has a little bit experience in Game Boy development, if you can just give me a pointer why I'm having ghost button presses, that would be quite helpful. So yeah, I have to change the script so that I can use the button presses, and then I switch back to GTA, and now, oh yeah, I have to, if I restart the stream, I do not have any means to synchronize between the Python script and the Game Boy Color, so I have to restart my Game Boy code in order for the frames to be in sync. By the way, you notice something. The Game Boy actually resets once. That's when the Wi-Fi cartridge connects to the Wi-Fi, and there's a really spike in the power or in the current that is drawn by the Wi-Fi module, and this caused the Game Boy Color to restart, which is not surprising because it's rated at, is this visible in the camera? Yeah, at 300 milliamps at 3 volt, and yeah, if you convert this up to 5 volts for the cartridge, which the Game Boy does anyway, and I convert it down to 3.3 volts, and these 300 milliamps are for the entire Game Boy. Yeah, I think the ESP would easily draw 200 milliamps when it just made the connection. It's not surprising that the Game Boy Color doesn't like it. But yeah, I will now start the stream. And we should... It's not working? Ah, come on. Why is it not working? Let's just try again. So, by the way, this is also an answer to all those who still ask if I want to sell this cartridge. It's quite a hack. I mean, it's nothing reliable. It's nothing I would really want to sell, and then yeah, be responsible for it to work for you. Right now, the ESP did not start up. Oh, it's having a blast here. I just hope that the batteries did not drain too much. So, as I said, these 300 milliamps are already very narrow for what we're doing, and as soon as the batteries are not 100% full, it's not stable anymore. It's not really stable in the first place, but, oh, come on. It just reset when I started the stream. So, once again, I hope you brought some time. I have plenty of time. My son is at his grandparents', so that's why we had to do this evening. By the way, another thing you see is there is a blank screen after the second. No, this doesn't look right. I think the batteries are already dead. Oh, come on. Huh? It's not trying the second time. What is it doing? Okay, I will just pop in fresh batteries. I thought they were fresh, but hopefully this helps. Okay, so then I continue explaining what I just wanted to say before the batteries died on me. I hope these are fuller. There's a blank screen after the Nintendo logo came up, before you see a black screen when the cartridge is waiting for the video stream. That's not really necessary on the Game Boy Color. This is mostly there because the same cartridge also works in the original Game Boy and in the Analog Pocket, which I have over here. And the Game Boy Pocket, the Analog Pocket starts up much faster, and I need to have a pause before the ESP is actually ready to stream, and it already connected to the Wi-Fi, so that's where I inserted the pause over there. But now I don't have a key input. Oh, come on, what's wrong now? Ha, 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 ha. Ah, no, it's stuck. Okay, that's okay. Next thing, you don't see now all the problems, and I hope this prevents you from asking for the cartridge itself. The problem I faced now is that I did not switch from the terminal where I started the script to the game, and all the the button presses were entered into the console until it complained about not being able to interpret some of the key presses over there. So let's try again. Ah, come on, I just gave up when it wasn't showing. Yeah. Am I already losing viewers? I mean, that's the first thing people will see about the stream when they watch it later, so... Alright, this looks good and I can control it. So here you also see these mistriggering buttons. It's also great that the game starts in the dark. That really helps to bring out the colors. But you see that, that I'm punching all the time. That's because I've got some mistriggers on... I'm not sure if it's A or B. I think it's A because that would be the right trigger. I mapped the controls so I can demo driving. So A and B is R2 and L2 for those who know the PlayStation version of the game. I try to get a car over here. Oh, yeah, and I'm pressing now the hijack the car button on the keyboard from the from the notebook because I didn't map it. And yeah, it's really easy to play this game with these controls. So I'm not even able to steal a car. Come on. Get into the car. No, don't kick the car. Okay. Yeah, so if someone can explain to me why I have these problems with the keys, then it would be really helpful. Okay, so now it gets better. I'm able to drive the car. Actually, doesn't look like a full frame rate to me right now. Not sure what's going on there. Okay. So yeah, to give you an idea about the latency, I think that's also something I owe you, is I will now press the button. And, okay, it's hard to see with the car how fast it reacts. Okay, so let's do a left turn now. So I think it's, well, for driving slowly, it's manageable, but in the end, I mean, honestly, I had so many people, especially when the large news blogs from gaming sites picked up, I had so many people asking why I do this and if it's actually playable. And I mean, I hope most people who are here today understand that this is mostly for the challenge of making it work. It's not a viable way to play this game, okay, I think. But you're probably not the audience I have to explain this to. Okay, so that's the GTA demo. Okay, right now we have... Okay, I would just move a little bit more because now we are in daylight, so maybe that's a better comparison. Also, the colors do not really pop out this much as the Futurama demo. That was another reason I did Futurama, because a comic or a cartoon obviously is better to present some colors. No car over here, at least not in range when I'm punching all the time. Where is the car? There's a car. Come, go over here, go over here. Get it. That's the way to stop a car. And now, okay, but for the red car, you can plainly see the colors. And of course, I'm kicking the car of some kind of gang or something. That's always helpful. And I'm driving again. And yeah, it depends when. So you can really see the colors in the sun, right? So like this, now you can see that it's a red car with the sun gleaming off the car. That's nice. But as soon as you're in the shadows or in the darker parts, then colors of the Game Boy Color are not that great. Also, while I'm still talking about the Game Boy Color, I will get to your questions, don't worry. The colors could be optimized quite a lot still. So what I'm doing right now is I'm using the palette conversion of the of FFmpeg. So I'm converting it to actually only 6 colors. The reason is that the Game Boy Color can do 32 colors on the background tiles that I'm using, but those are in 8 different palettes with 4 colors each, and each tile of the image can actually use only one of these palettes. And that's something you cannot explain to FFmpeg. So I need to set up those palettes so that all possible combinations of all this dithering, because you really want that dithering in there, from FFmpeg can be represented with those colors, and there are so many things that you could do to improve this. First of all, I could write my own algorithm to actually respect this limitation of the Game Boy, that the tiles are limited to 4 colors each. But there are also tricks like changing color palettes mid-frame by swapping them during H blank. So there's quite some room to improve on the colors. But yeah, and also this glitching. That's what I mentioned in the other short video. I think that's a timing issue of the ESP. I don't think, at first I thought it was a timing issue of hitting H blank, so like in the original Game Boy demo, I'm transferring all the tile data in during H blank, so each time the image is drawn outside this region, so to say, instead of V blank, because there's just still more headroom in there, but I think that timing is okay, because the glitches would look different if I just were not allowed to I think I should move this scene, or this will be rated, what is it, this R rating, if it's too brutal. I don't think that counts when it's on the Game Boy like this, but this guy was just kicking this guy's face on the floor. Yeah, that's Trevor for you, for anybody who has ever played GTA 5. So yeah, there's still some room for improvement, and these glitches, I think, are a timing issue of the ESP to the transfer to the Game Boy over there. And it's really not full frame rate. I think that's FFmpeg with the grabber, but I'm not sure, because the Futurama demo really ran really smooth. Okay, so finally, let's get to your questions. So let's just have a look at I will just quickly have a look at the chat stream to get an idea what's going on. Okay, so I hope you understand I cannot read the entire chat while talking, so I will look at those questions, and oh my god, there are plenty. Okay. Okay, yeah, the first one is alright. So let's start with this one. So first question is if there's a bill of materials to easily order the Wi-Fi cartridge parts. There in the oh, I didn't support these smileys, I see. In pretty much every video, my blog is linked, so that's there ought to be. So this is actually an URL. I should have some kind of overlay to show this. So yeah, it's there, :orte::b, but it's also linked below every video. And I think in the GTA 5 video, I mostly explain how the video streaming works, but there's also a link to the original Wi-Fi cartridge blog entry. And in this blog entry, there's a link to a GitHub repository with all the code and the PCB designs. And there's also in this blog entry a bill of materials. There is also a link to, I think, a Mauser shopping cart for those of you who want to order there. Not that I would particularly recommend them. There's nothing bad or good about them. I do not have much experience with different suppliers, but that's the one I used for this project. And someone asked on GitHub as an issue that I should also offer a bill of materials in CSV form, and I also committed this one a few days ago. So I think there are actually 3 types of bills of materials. Only problem is, as everything that you want to order right now in electronics, I think not all parts are available anymore. That's just, yeah, the common problem. Okay, next one. Where can I buy this card? Seriously? But I think I answered this after the question came. So yeah, to mention this once again, you've seen all the troubles I had to get it working on a live stream. I'm really prepared to show it. Yeah. This is nothing I want to sell. This is a project I pushed to the point where I can demo it, but being able to bring it to a form where I can sell it is far beyond that. So I would need to add, for example, there's a menu to enter your Wi-Fi credentials. You enter your Wi-Fi credentials in the source code, so you have to compile the code and then hook this cartridge up to a programmer. So you have to hook up 4 cables to these pins over here. Use the Arduino IDE to compile the code, and then, yeah, that's not a beautiful contraption, but it's honest. That's the programmer I used. So you have to hook up all these cables over there, and then send the new program with your correct Wi-Fi password to the cartridge. And that's just one of the many issues there. So, and as you see, as you've just seen how to set up a video stream and how to change it in the, so you need to adapt the Python code to get the right video source onto the Game Boy. It's no project that one should sell. And to be honest, if you can manage to program it like that, and if you're also able to, for example, program the EEPROM to switch to a different code, for example, if you do not just want to do the streaming stuff, then it shouldn't be a problem for you to build the cartridge yourself. I mean, the PCB files are there. If you have never done this, it's quite easy to. You can just grab the Gerber files from the repository and order the PCB. You have to do some soldering. And if you really say you are such a software guy that you oh, I didn't even show the question, so the markers will be off, doesn't matter. So if you say you're really just a software guy and you cannot solder for your life, then I would recommend, that's what I usually recommend there, ask around at some local makerspace or hackerspace. You probably find a student who's happy to earn a few bucks to build this thing for you. Okay, so that would be my recommendation there, because I really don't want to deal with setting up a company, dealing with the regulations from all the countries, and dealing with those who are not satisfied with how the cartridge works out when they finally got it and realize that it's too hard to get it to work. Okay. Okay, next one. Okay, yeah. So what caused the glitches? Oh, I shouldn't have popped this onto the screen. I have to work on the chapter marks later anyway. Yeah, I answered this during the stream, so I think it's the timing of the ESP. Okay, next question is one I get so many times, so yeah, I get it in here, so I can mention it. Yeah, you're wondering if I'm German. I'm not sure if you're German yourself, because I get this mostly from other Germans than from people around the world. Or no, it's different what I get from other Germans. So yeah, quite obviously, or at least to other Germans, it's quite obvious. Start my stream with Moinsen, so I don't try to hide it. Moinsen is a greeting from the northern part of Germany. I'm not from the northern part of Germany, I'm from the west, so yeah, I hope the guys from the north excuse me using this, but I really love the word Moinsen, and I thought this would be quite unique. And yes, I'm German, my accent is quite obvious. Interesting thing is I get a lot of shit from other Germans about my accent who cannot stand hearing my accent, and I do not hear this from international viewers, so not sure what's up with this, but yeah, I can't hide it, I'm from Germany, that's right. Next one. Yeah, Cyberpunk 2077 on Game Boy. When? Yeah, I don't own this game, so I'm not showcasing it today. Also, yeah, if you got requests of things that I should show on the Game Boy, in principle we can do this. Problem is, if I don't have the game, I'm not buying it right now. I wouldn't mind if it was a few bucks, but I'm also not downloading a several gigabytes game while I'm doing a live stream. So there's no way we can show anything that I do not already have here. So that's quite limited. Okay, this is quite technical one. I think I will skip this for now. Okay, we'll skip this as well. And so there are some that I skip right now just because I think they're quite technical. I wanted to push the technical stuff to the end, but I also talked about so much technical stuff, doesn't matter probably. Okay, next one. How much time did you spend on this project and what was your biggest hurdle? That's really hard to tell because I think I found the Game Boy in my parents' attic, was it autumn? Not sure. July, August, maybe September, but something around then. And I started quite soon after that, but I have a daytime job, of course. I have a family. I've got kids with the age of 1, and the other one just turned 3. So it's also a time where they do not hurry off into their room to how should I say it, to play with their own friends or anything. So on the weekends it's family time, in the evening it's family time, so I can only work on it when I do have spare time in the evening and not other things to catch up with. So it's really hard to say how much time I actually spent on the project. And the biggest hurdle, so hard to say. I think I've spent quite some time researching in the beginning because I'm really not that much of an electronics guy. So I went in many bad directions first when designing the PCB before I had the idea on how to do it right now. And actually, I learned so much from posting this video on YouTube from other people who made suggestions below the video. So if one of you is watching this, thanks a lot. I could not answer all of them because usually if I answer a technical question or like, why didn't you use, yeah, then yeah, you get 3 follow-ups, and I couldn't keep up with the comments anymore. But I learned so much from these comments and alternatives on how to create this. And I think I spent quite a long time designing the PCB before I actually ordered the first version. And the first version, I've got it over here. Don't worry about the additional cables. I use this to do some debugging just to get the pins out of the Game Boy to my oscilloscope. But there are so many bad things. So the obvious one is that I had the wrong footprint for, why is it so dark? I had the wrong footprint for this socket. I just designed it for the EEPROM without the socket. But that's only a small problem. That's a little mechanical problem that was easy to circumvent. But I even made the mistake of using the pins on the ESP that are not usable as GPIO pins. I used an ESP12F before. I'm not sure if I was just lucky that I didn't use so many pins, but this thing has so many bad decisions and mistakes in the design. So I think that was where I spent most of the time. And once the hardware was ready, yeah, there are many things where I get stuck while coding, but that's fun stuff you can do on the couch and where you don't have to solder stuff and sit on your desk where you've got an oscilloscope and everything. So yeah. Hope this answers the question. Oh yeah, that's also one I heard several times. Have you considered putting an external battery in it? Not really, because it feels like cheating. I mean, the fun idea is, I mean, it's not practical anyway. So all the rules that I'm saying right now for this project are quite arbitrary. But the goal of the project was not to actually watch videos on the Game Boy or do anything like this. The goal for me was to create a cartridge that just works on the Game Boy like any cartridge would do, and that has Wi-Fi. And adding a battery to it, it doesn't really feel right, I think. I mean, yeah, you could do this, I think. You could also get a power adapter into this. It's just, I don't find it too appealing to do this. Yeah, short answer. So, next one. Okay, I'm not sure if I understand this one correctly. Was the retro-looking PCB done on purpose? And if so, how did you achieve the look? I'm not even sure, but okay, I didn't know that it looks retro. It probably depends on what you compare it with. My previous design, so this is the first design I did with SMD components. I never dared to, I wasn't sure if I was able to solder this, so I didn't trust my soldering skills. I'm not sure what it makes look retro. Maybe the green PCB. I ordered this from Eisler, mostly because we do this from work. So I work at a university, which is public money. So which means that we have to obey quite a few rules. So we cannot order directly from China, or at least you have to have a very good reason to do this, and with a lot of complicated rules. So we have to order from. So I knew Eisler from there because that's really next to where I work. I could almost walk there. So that's what I knew. And they only have the green ones. I think that contributes to the retro look. Also this brownish socket. I have no idea why it looks so brown. Then of course using an EEPROM is quite retro. I'm not sure if I would use an EEPROM again, but that was the easiest way to go because that was the thing that directly works in such a cartridge. And the rest, I'm not sure what makes it look retro. The other things are just maybe the size of the components, because I went for the larger SMD stuff. As again I said, I wasn't sure about my soldering skills. I did not use reflow soldering. Maybe that's what I try for the next project to get smaller. But I soldered everything by hand, so maybe that's why you say it looks like this. Or maybe it's just the look of a Game Boy cartridge. Not sure. Yeah, someone in the comments said, Zoomers nowadays think that green PCB is retro. Maybe, that could be true. But yeah, that's mostly from those of you who look at PCBs that are visible to the customer. So if you're buying a mainboard for your PC, then nobody sells a green one because that really looks retro. But I think if you open any device, they are usually blue or green, I would say. There's no reason to get a purple PCB if you manufacture a device where the user shouldn't see the PCB anyway. Oh, by the way, I also ordered a new batch from GLC PCB, so I do not have to just mention Eisler here, and those are actually purple, so if they look less retro, I haven't tried them yet, I didn't even open the sealed back yet, so to minimize any oxidation before soldering, that's not much of a problem in these larger ones, but they just arrived today after spending 12 days in customs. That's the downside of ordering them from China. But I have to say the ordering process was a bit nicer with more options, and I had some bad experience with Eisler before, so I tried GLC PCB for the next batch. And also, by the way, there's not much of a difference. It's the same PCB without the mistake that Eisler did. And I'm trying another voltage converter because the one I used before wasn't available anymore, and I think the other one might be a little bit more stable. And it's mostly for for a YouTuber, one or two, to whom I want to send a version to either make a video about this, but also I think there are one or two YouTubers which I enjoyed watching throughout my entire life. I don't think that this thing matches their channel, but I think they would enjoy receiving one. So if I find some time, I will build one or two more. Okay, so that's a retro question. Everyone knows red PCBs go faster. Okay, should have thought about that. Yeah. Okay. Next question. Okay. Now that's rather technical ones. Are you streaming UDP packets? To the Game Boy, not. I think so. I haven't changed the code in a while. So today I thought about this because before I figured out what FFmpeg did, I tried to get the GTA stream running by capturing it from the, so I have to have something in the frame, by capturing it from the laptop through an HDMI grabber, and I had to send the inputs from the Game Boy back to the laptop, and I did this via UDP because it doesn't make sense to use TCP for this. I have to look into the code. I think it would make sense, but then again, I'm not sure. You have to look into the code to be sure. It's been a while since I wrote this part. So back when I did the Star Wars demo, I think after that the part of the code that actually sends the packet hasn't been changed. So yeah. Next one. Okay, that's also a common one. I like to answer this because this is also one that comes often. Will there be a Game Boy Advance version? That's a cue for me to explain what I want to do next. I don't think so. Before so many people asked about the Game Boy Color version, I didn't even have a Game Boy Color, so that's also a reason that there's still the glitches and everything in there. It just arrived, when did it arrive? Last Friday? I think so, something around that. So after I got so many comments, I ordered one from eBay, and I quickly made it work then. And the reason I went for the Game Boy Color is I think it's more interesting to do this on the older consoles, because that's really, that's the part I enjoyed about this project, to work with a limited toolbox of the device and to make it work there, and not that much tinkering about the own electronics part. And the newer the device gets, the harder it gets to communicate with the device through the memory bus. At least I think so. I haven't looked into GBA stuff. Also, if you go for really new devices, then it might also be a problem of reverse engineering how they work anyways. And that's something for the Game Boy other people did for me already. So I have to mention this certainly. I'm standing on the shoulders of giants here. So for many years, there has been an active Game Boy development scene. Actually, many of these parts I only noticed after posting the videos. So if I think some of you are probably watching, you're doing great stuff. I really enjoy many things that I learned by now. By the way, also there's an interesting project which someone mentioned to me after I posted this other short one, where there's actually a video player for the Game Boy Color. I haven't tried it yet, but it looks more stable and better than what I'm doing here. Although I cannot directly adapt it because it uses DMA, which wouldn't work with my Wi-Fi cartridge. But there's so much interesting stuff. The only problem is, for anyone who's searching this stuff, you first find very old documents, which are already great. Then you find a wiki with the new information, and on top of the wiki there's the link to Pandocs, where is the current stuff, and from there you usually find the forums and where all this development is going on. So I hope I got this right. If someone from the who's active in this community wants to me to mention some kind of link, post it as a question so I can see it later, and I'm happy to mention this, because I during this project, or actually mostly when I got done with the project, I only learned where all the great information is hiding. But back to this question, so newer stuff, this could be a problem at some point, which is also an interesting task, but it's a different type of task. And yeah, I also don't own a Game Boy Advanced, and I think by now I'm pretty much through with this topic. Doesn't mean that I'm not doing retro stuff again in the future, but I think after this video tonight, I will let this project rest, and hopefully we see developments from other people. But I do not want to spend the next months posting another video and another video, another video just on a different device. So maybe I come back to the Game Boy in a few months after doing another project. Maybe I come back to Super Nintendo or something like this, because I really enjoyed this this development on the retro stuff, because it's like you have a toolbox with very limited set of tools, and it's like a puzzle, and it's really a challenge to get some things working with this, but it's still a system where you understand every single part in it, and so that's quite a lot of fun. But I do not want to flood you with one video of a Game Boy after another. So I think I will not do a Game Boy Advance version soon. Okay. So next question. I'm still at the questions from now 9:15. So, but I think soon the question will repeat, so I can skip faster through them. Okay. Okay. So there's a question about the battery again. We had that. How's the range of the Wi-Fi signal? I haven't really tried it. I have to say I've got some problems here in my office in the basement, but I always have these problems also with my laptop in some places. Most of the stuff here is connected through Ethernet because of that. So it's not unusual, I think. So this is more a question about the ESP. If you really want to know if you can watch video through your Game Boy somewhere out in the woods or in your garden, you have to check out how ESP8266 does with the Wi-Fi signal. I think there shouldn't be much of a difference. Maybe the power consumption goes up if signal is too bad. Not sure about this, and then you might get some trouble, but it's not a practical build anyway. So yeah. Is it possible to use the Game Boy as a Wi-Fi access point? Yeah, you can use the ESP as a Wi-Fi access point. I'm not sure where the Game Boy comes in there. I mean, yeah, so this is the ESP. This is a common microcontroller. You can also get this as a development board, which is easier to handle at first when you're starting out with this kind of stuff. And with a few lines of arduino code, you can make it turn it to an access point. And you're probably asking if you could stream to the Game Boy without having network infrastructure, right? That's possible, I think. I'm not sure if power consumption would be different. I'm also not sure if there's a problem with DSP having very little extra spare time to handle the Wi-Fi stuff, because it's spending so much time communicating with the Game Boy, and it's a single core device. Also, many ask why didn't I use a ESP32, which would be a dual core and faster, more modern microprocessor. The honest answer is I had a few of them still around from a previous project, and that's why I used them. So in theory, I think it should be possible. You would have to modify the Arduino code a little bit, but not by much, so that it starts as an ESP as an access point, and then you can connect to it from some other device, and then again stream to the Game Boy. I'm just not sure if there would be a power problem if it consumes more power and then really gets into trouble with the Game Boy. I'm only mentioning this all the time because these devices are really on the edge of what they can provide as power. Okay, so next one. What programmer do you use for the ESP8266? Actually, it's not that relevant. I have this fancy programmer here, so yeah, it looks a little bit weird because I'm just using it as a serial adapter right now. So this programmer, oops, it's the other way around. You can pop one of these into there. Just wait a second. I grab one from the drawer. So yeah, let's move over here. What I'm showing this, I think I can move out a little bit without revealing too much of the chaos over here. And I think for this I can turn off this lamp, this light. So this is what these ESPs look like if you get them individually. Also for most of you, if you're just starting off with this stuff, you are getting something like this. This is actually an ESP32, and you get a development board like this. But if you integrate it into a cartridge, you want to use the small bare bones one without a USB port and everything. And to program it, you just need any USB to serial converter. Actually, if you are already playing with some kind of microcontrollers, you can also use one of these development boards as a USB to serial converter. You have to Google this. I do not know it exactly. You have to, I think, pull the reset pin, the enable pin to ground permanently, and then you can just use the TX and RX pins as a serial programmer. I'm not sure, you have to look this up, but it's quite simple to use these as a serial programmer. What I have here is this thing, mostly because it's able to simply get the ESP in here and program it directly. That's the only reason I have this device. For the Game Boy programming, I still use this one, simply because it's a USB to serial programmer that I have already available, but you see I just hooked up a bunch of jumper cables, so I can get these hooks over here, which I can then connect to these loops, these test point loops on the cartridge. You cannot see anything because the focus of the camera is all over the place, right? Let's see, I should probably fix the focus. I don't think that there's much stuff sticking out anywhere, and then I can manually correct it. But the entire image is wobbling if I touch the camera. Sorry about that. I hope you don't get seasick, but it will stabilize quickly. I can also stop it down a bit. I think it's bright enough over here, so we do not have to worry about a shallow depth of field. So, okay. If you're asking about it because you want to program the Wi-Fi cartridge, just get any USB to serial converter, or if you already have one of the development boards for some kind of microcontroller, look up on the internet how you can use them as a serial programmer, because you can use them as well. If you're asking in general because you want to program ESP12Fs before soldering them, it's usually not really the best idea, because usually after soldering them you want to change the software anyways. These things are quite nice, but mostly for the first programming, so you can get an over-the-air update software on it, and then you can update them later anyway, hopefully. Okay, so back over here where the camera is. Next one. Will there be a save of the stream? Yeah, if you have to leave, or probably, oh no, it's not that far. Yeah, it's 20 minutes ago. So if you have to leave, I think YouTube will keep it on the channel anyway, if I don't delete it. I do not intend to delete it. I think it should stay available. At least I hope so. I'm not recording it, but I think it should stay available. Next one. Okay, it's getting technical anyways. It already got technical, so why not? Did you consider using different programming language? Maybe PlatformIO instead of Arduino IDE? Yeah, at some point I thought I would have to. I mostly used Arduino because that's what I was used to, which I already knew. Turned out that I didn't have to, because I think most of the bad reputation that Arduino gets for being slow, if that's the reason you're asking, is because the convenient Arduino methods are extremely slow. If you look into what the typical setup pin, is that the command? Yeah, I think so, actually does, it's total overhead. And one of the problems I have with this setup is that I need to switch between input and output for the GPIOs very quickly, depending on whether the Game Boy wants to read to the ESP or wants to read from the ESP or write to the ESP. And that was something where I wasn't sure if I could be fast enough, but if you write directly to the registers, Arduino was fast enough too. At some point, I'm probably trying some of the other, some of the alternatives of the Arduino stuff, but yeah, for this project, it was fast enough. I mean, the thing is, Arduino has a bit of a reputation of being the beginner stuff, but yeah, it's fine, and it's the nice thing about the Arduino stuff is that there are a lot of libraries already available. They're not the fastest ones of them, but before I got the video stream running, I thought about doing some other gimmicky stunts with the cartridge. I didn't expect that I could stream video through this when I built it. I thought about doing stuff like sending MQTT messages to control lights through the Game Boy, or open my garage door with the Game Boy. I never did this because I figured out that the stream is working, and after showing the stream, I'm not sure if this is impressive anymore. But before I thought about this, the advantage of the Arduino stuff is that there are a lot of libraries for pretty much everything there that you can just pull in there, and it would be easy to adapt this for stunts like showing this MQTT stuff for home automation, showing other websites using other interfaces, and using pretty much every library that's available there, and that's quite a lot of libraries. But yeah, I haven't checked out other platforms and other programming languages so far. From work, I had this first look into MicroPython on the ESP32, which is quite interesting that it's even possible to do this. So for those who don't know this, from the with MicroPython, you can start pretty much load an image onto the ESP and then simply log into it via the console, and so the serial monitor serial console, and just type your commands in there. They're interpreted by the ESP directly, so that's also quite interesting. Okay, next one. Okay, I think I will also do the ones that I skipped before because I thought they would be too technical, but I think I just go through them as they come in, hoping that eventually I catch up because there will be duplicates at some point. Can you selectively update only certain pixels, or do you have to send all the data every frame? The way I'm sending the stream right now, the Python script cannot change the order. But if you change the code on the Game Boy, it would be possible to come up with some kind of protocol where you submit coordinates from the Python script, and the Game Boy will only update those coordinates. So from the Game Boy point of view, the code can update any tile at any point it wants to. And from the point of view of the Python script, of course, you could do the same. If you're doing full motion, that's probably the right word, full motion video, it doesn't make sense. It would mean a lot of overhead because you have to communicate if you want to update a certain pixel or the entire screen, so it's easier to just stream all the data after another. But if you're doing something where you want to update only certain parts, I think updating a single tile, or at least one line of a tile, would be more appropriate, but it would be possible to change the code to do that. So if you've got something like a static image where you only want to update certain parts where some text or some status icon change, then this would make sense. Yeah. Could you explain? Could you explain the color quantization conversion mapping procedure between media source to Game Boy Color? That's the big technical one. I should probably have saved this for later, but yeah, my tool cannot store them for later, so let's go with it. Okay, so actually the quick answers, what I'm actually doing is quite simple in a certain way. What I'm doing is I tell FFmpeg to, so wait a second, I can also bring up the code on the screen. I think that's a good idea. Only problem is I'm using the same screen now for the preview, so I have to check if it's working. No? What do you see here? That's... No, you're seeing a different screen than I thought you would see. Okay, let's go over there. Is there something incriminating on the screen? No? Okay, great. Let's pull up the font size a little bit. Okay, so you see there's a lot of stuff commented out from different commands that are sent to FFmpeg. The one so this is the command that's not commented out right now, is a way to stream video from my smartphone. Actually, that's because at first I thought I used this as a camera for the greeting part. I mean, I can show what it does. Come on, is it working already? If it boots up properly. Oh, no. Oh, there's no cartridge in there. Yeah, of course it doesn't work. And you're not seeing what I'm doing anyway. So let's put in a cartridge. Or the cartridge. Oh, it's still turned on. That's also not ideal, but yeah, I'm used to the original Game Boy, which wouldn't allow this. And let's turn on the light so you can actually see something. Let's hope it works right away. And okay. Let's try it. No, it's not working. What's not working? There's actually a problem in the code. A connection refused. Okay, so the streaming on the phone is not on. Let's try again. Something's happening. Oh yeah. So yeah, I can show you my setup on the Game Boy Color. Oh, it's sideways. Sorry. Okay, and yeah. So if you like Inception. Oh no, I've got the phone in the way. Okay, so you got the idea. That's the code I'm showing here. So let's switch back to the source code. I know some of you would prefer to just see the demo. So this is this part of the command. So it's FFmpeg. Some commands to disable the output that FFmpeg does because it's just getting in the way. In the end, this is the stuff to pipe the result into Python via a pipe, and this is the relevant part that gets me the stream. This is getting the stream from a certain from the IP address of the phone when I have the streaming software running on the phone. And this is where all the magic happens. Let's copy this to another editor so I can easily dissect this a little bit. So this is a filter complex command which allows to get a lot of filters into FFmpeg. So what I'm doing here is I crop the image down to something that has what is a 10:9 ratio because it's 160 pixels by 144. That's 20 by 18, so 10:9 aspect ratio, so I always have to crop everything that comes in. Then I scale it down to the 160 by 144. I actually boost the saturation a bit. That's mostly because the color mapping of the Game Boy Color is not the same as on a screen that you're used to. It doesn't have background light, so a full bright red is still far from being a full bright red. So I increase the saturation with FFmpeg right away so that the colors come out a little bit more, because if you just use the same colors from the screen on the Game Boy, you do not see much of a color that you would expect, because it's simply just a different way the colors are mapped on the Game Boy Color. I split it into two because we need one of the streams for FFmpeg to generate the color palette, and we need one to output to the Python script. Then yeah, this is simply to pad some part of the output that's not too relevant. Oh, I can show you the result later. Maybe if I show it at the same time, this also helps to understand what I'm doing here. Just a second, I have to search my system for what I want to show right now. I think I still have it in there, or did I delete this? I deleted this. Just a second, I can reproduce it, I think. Yeah, that's always good to do live. But I think the command is still in here. No such directory. Yeah, I'm outputting it to temp. Okay, great name for directory. Let's call it temp and do this again. And I don't have, it's the wrong one. I actually did it on the laptop for the last time. Okay. One last try. You will not spend the evening now watching me trying to figure out which command it was, but I think I can quickly show this, and that would be quite helpful, I think. No, the command isn't in here as well. Then I put it just together, so I copy this part and put it into the command. So yeah, I can show you what I'm doing here, so that's probably more interesting. So I'm using the same command on the command line right now because I want to output it to an actual image file, because you cannot see what FFmpeg outputs to Python otherwise. Yeah, and that's one of the old commands with which I tried to get it to work. I'm not sure what was in there. So this should probably work. I will turn on the stream on my phone again, so we have something to look at. Maybe just the wallpaper right now. Come on. No, that's still the wrong one. Wait a second, what is complaining about? Palette color PNG. I'm not using this one anymore. Okay, it's still in the old command. So one of my earliest approach was to actually give a color palette to FFmpeg myself, which turned out to give horrible results. Oh, okay. It did not. Yeah, in the command there was still a Futurama video. You see it over there. Okay, so we have gotten Futurama as an example of what's sent to the to Python. This is a little bit small, and if I scale it up, you get some filtering. So I open it in GIMP instead. Let's use a frame with a little bit more going on. This looks nice. Let's see. So this is what FFmpeg produces for the. So this is just a scene when the camera starts to move towards the city for the intro of Futurama. So for those who haven't seen it, that's the source material. Oh, I should turn down the volume. Yeah, it's the intro from the great TV series Futurama, and I think we already are beyond the scene that I'm showing right now. Are we? Or is it here? No, that's the end of the intro. So we're somewhere. Where's this building that looks a bit like the shard? No? No? Huh, okay, it has to be somewhere in there, but you get the idea what the source material is. I cannot find the building from the picture right now. It's maybe in this scene? No, the spaceship isn't in there. Doesn't matter. So that's why in this code I split the input, because one part of the input is it's actually the frame that's going out to FFmpeg. Not to FFmpeg, to Python. So it's this part, and the other part of the screen is used to generate the color palette. Yeah, and this black part is just for this padding here, because otherwise FFmpeg would complain. So this is just creating this long bar over here. So one of the streams goes into palette gen. This is a command to generate the color palette. And I tell it to only use 6 colors. I will explain why later. And I tell it to use it to generate a new palette for each frame. To not use transparency. That's for GIFs usually. And then I split it again, because one palette is used to actually be applied to the image, and one palette goes over here into this corner, so Python also gets the actual color palette. So that's the 6 colors FFmpeg used for this frame. 1, 2, 3, 4, 5, and the rest is the sixth color. And the other commands after that are applying this palette to the original stream, giving us this nice picture, and then using HStack and VStack to combine them to one single image. And what I do in Python then is I have the problem that how do I show this? I think it's time to do some drawing. Okay, and I have to switch the screen that's actually shared. Just a second. So which screen is the right one? This is the one. Ooh, that's trippy. Okay, so I think you should see this, right? Oh yeah, it's there. Okay, so the problem is we've got, in theory, we would have, on the Game Boy it works like this, or the Game Boy Color it works like this, that you've got 8 color palettes, and each one of them consists of 4 different colors. And when you construct your image, then for each tile, you can choose one of these 8 palettes. So you've got more and more and more, 8 of them. So each tile can pick one of these. And the problem now is that FFmpeg doesn't know about this. So if I give FFmpeg a specific palette, or if I tell FFmpeg to generate the palette itself, then we get, for example, these 6 colors that I just applied are scattered across the entire screen, and FFmpeg doesn't care that for this 8x8 tile, it can only use 4 of these colors. So the problem is, when I set up these 8 color palettes, I have to get all the combinations that could possibly in there. Okay, so my first approach was that I said, okay, let's put black in each of these palettes, let's put white in each of these palettes, and then use primary colors throughout the 8 palettes, because in theory FFmpeg could just mix those together with dithering and it would look quite nicely. The problem is FFmpeg then also dithers between neighboring colors. So if you have red and green, red and yellow in those, so or red and green would also be a good example. Let's stick with red and yellow. So you've got red in this palette and yellow in this palette, and what then FFmpeg starts to do, if there's some orange in there, it dithers red and green into red and yellow into the same tile. And you do not have any palette that works with this, and the image looks horrible. So in the end, I had to apply some math. So how many combinations can I represent with 8 palettes? And yeah, the answer was that I only have 6 colors that I allow FFmpeg to use. And yeah, so if you combine 4 of them into one palette, then yeah, for those of you who know a little bit of math, that's combination. That's the binomial coefficient. How do we pronounce it in English? If you know what I'm talking about, you know it. Otherwise, you probably do not care. So if you pick 4 out of 6, there are 10 possible combinations. So I discarded 2 of them, which I think are less likely. So I took the combinations with the 4 brightest colors, because that's the probable ones to dither between them. It doesn't make sense to dither between the brightest and the darkest color if there are some in between. The same for the 4 darkest colors, and then I had the idea that for parts of the image where there's huge contrast, I take the brightest and the darkest one, and then yeah, use all the 2 combinations that are possible between these for the other remaining 6 palettes that I have. And the only ones that are not represented in there is where you get the darkest color and the 3 other ones, and the brightest color and those 3 other ones. And then I go through with the Python script, I go through the entire image that's generated by FFmpeg, and for each tile I then simply calculate which palette is the closest one to what I actually should represent there, and replace those colors that are not in the palette. In the case where there are still different colors mixed in there, I simply replace them by the nearest color, and that's how this works. And the all the time I'm showing something on the actual image over here. So yeah, so that's the image I was talking about. So if for each tile in there, I then look for the palette that's the closest one. And now let's get my setup back so I can see what I'm doing here. So the problem with this is mostly that I'm using FFmpeg for all this stuff. I had a few days to get it running if I wanted to get it early before the stream today. So I decided to use FFmpeg for it. The solution to get better colors in there is, of course, to write this script on yourself, for yourself. So with including the dithering and including the generation of the palettes, and then take into account the limitations that you have. And there's a lot more possible, I think. But yeah, that's the best thing I could come up with on the short notice to use FFmpeg for it. I hope this answers the question. That's the solution I'm doing right now, but there are better solutions out there, I'm quite sure. Okay, next one. Hopefully something less technical, but I'm not losing too many viewers. That's nice. I think it's probably mostly the technical inclined ones that's watching this anyway. Okay, next one. Are there any planned upgrades or revisions of the cartridge? That's similar to a question earlier if I want to do Game Boy Advance version. I think I will close the project for a while now. I'm not sure if I think others will probably pick it up. It got quite some attention, so I would love to see upgrades by other ones. The thing I would love to see is if someone with more experience in electronics can fix the power problems and make it more reliable maybe. Also, I would then love to see some of the Game Boy development community to pick up with a copy of this cartridge and show what they can do with it, because they've got much more experience in this. But I would probably look into other projects for a while. I will get back to the retro stuff, I'm quite sure, but I do not think that I will do more revisions. There's one revision coming with another voltage regulator, which I hope is a little bit more stable, but that's nothing. It's just a change in the bill of materials in the end, if this works out. Oh yeah, same same answer. If I want to do something similar for the SNES, maybe, not sure. That's one of the projects that might lie in the future. Although I'm not sure if I'm doing the same type of thing. Maybe something else with the SNES. Many possibilities, but SNES is definitely, that's one of the consoles I owned as a child. So that makes it interesting to me. I never had an NES, but the Super Nintendo is the one that I have the most fond memories of. So that's the interesting one. Okay, I remember that there was a way to play Game Boy games on PS1 using parallel port. I have no idea how this worked. I cannot tell. It doesn't ring any bell how this works. And I never owned a PlayStation 1. I have no idea how stuff is played on the PlayStation 1 there. I'm not sure if there's an adapter that just that's acting like a Super Game Boy is mostly the same electronics of a basic Game Boy, just with an output to the Super Nintendo. If it works like this, then the cartridge probably would work in there as well. If it's something that plays ROMs, it wouldn't work. But I do not know this type of hack there. So yeah. Yeah, that's a similar question. It's one that surprised me a bit that I got it so often. If I can emulate the cartridge on an emulator. No, your emulator doesn't know how to emulate the Wi-Fi chip. So you could write an emulator that emulates this cartridge, of course. It's actually quite simple because the cartridge there is only one memory address that's used to, or actually two memory addresses that are used to communicate with the Game Boy itself, so it should not be too hard to write an emulator for this. But then you would also need to emulate the Arduino code on the cartridge if you really want to fully emulate the thing. So yeah, you would have to write an Arduino emulator as well, or an Arduino emulator to emulate the ESP, something like this. So I was quite surprised how many people asked for the ROM of what I'm showing there. I'm not sure if this were just some gamer kids who saw the news flash on their gamer side and saw GTA 5 on the Game Boy and thought they could just download a ROM to play it. Although I think I made it clear in the title of the video and right at the beginning. But it would be possible to emulate the cartridge, but I'm not sure if this really makes a lot of sense. So and not with the existing emulator. You could create an emulator that emulates this. Would be nice for development of this thing, but by the way, you can actually load the code that's on the EEPROM into an emulator and run it. It just doesn't do much because it doesn't get, so from these two addresses that talk to the ESP, it always receives the same value. So you can admire a black screen for the streaming thing. For the Wikipedia example, you actually see the start screen of this Wikipedia thing. So this part I could do on an emulator instead of restarting the cartridge all the time. But beyond that, nothing's happening there. Next one. Would you redesign it if you had the knowledge that you have now? Yeah, there are quite a few things I would change. I learned a lot about different components that are available that could be used. I'm quite intrigued by these dual port RAM things that were mentioned. Not sure if this would work. I didn't look that much into them, but those sound quite interesting. I see that for some reason the questions pop up much later than they should. Should be showing it right now. Just a second. If I refresh it. There it is. Okay, sorry. So I learned so much from the comments below the videos that I could improve on. I think I also had some better idea on how to protect the memory bus of the Game Boy, because as I mentioned in the first video, yeah, any bug in the software means that there's a short circuit in there. So if the ESP tries to write to the Game Boy at the same time that the Game Boy tries to write to the ESP, that's bus contention. That's what it's called. It's on this communication bus. Both ends try to set a certain voltage, and if it's not the same, and it's 1 in 256 cases, so 8-bit is a chance that they actually want to set the same, and even then it's not ideal. It's basically a short circuit. Luckily the Game Boy only restarts if that happens or browns out or something like this, but by now I know some better techniques to prevent stuff like this and some components that would be helpful. So yeah, I learned a lot of this. Also one question I got a lot of time, not sure if it's in there later on. See, can I search in here? Question's not there. Many people asked where I learned to do this kind of stuff, and I learned it from projects just like this, doing things that are a little bit above my head or my current capabilities, and not too much because then you usually fail, but if it's a little bit more complicated than what you can do at the time, you learn a lot of stuff, and just the list of things I learned from this project is so long, it's amazing. So yeah, I would definitely change a few things if I would design it again, but yeah, I don't think I'm designing it again, so at some point I think I had enough Game Boy for a while. Next one. Yeah, are you happy with the microcontroller you chose for the project? If starting over, would you do anything differently? I think I would try an ESP32, but I'm not sure. There was some discussion below the first video, mostly that was the one more about the electronic stuff. Some people claim that the timing of the interrupts is even worse on the ESP32, so that might be a reason not to do this. I think I would still go with the idea that I only use specific addresses, which I select via logic, simple logic modules. That's not the word. Logic gates. Yeah, through different logic gates. Some people asked if a faster microcontroller could do without the logic gates, but logic gates are such a basic and simple tool, and they really take a lot of load from the microcontroller. Some people also said I could use the highest address pin as a memory select, but still the operation codes for the process of the Game Boy are still running from the EEPROM. And if I didn't do this, they would be running from the microcontroller, so I would still use this way, and this still means that I'm limited by the response time of the interrupts. And if the ESP32 really has a little bit less reliable interrupts there, as someone mentioned, I haven't checked this, then it would not be such a good decision, but the advantage of the ESP32 is that it actually has 2 cores, and so I would not have to worry that much about giving the ESP a break to do the Wi-Fi communication in the meantime. On the other hand, I suspect that the Wi-Fi libraries from the ESP expect that one of the cores can tend to the Wi-Fi all the time. So maybe this is even worse because I could not use the other core because it doesn't. In contrast to the ESP8266, which only has 1 core, the Wi-Fi library has clear rules on how long you can do your own stuff before you have to give it time to do the Wi-Fi communication. If the ESP32 library expects to have a single core for its own all the time, it may not be that helpful to have that. But yeah, I think I would try an ESP32, definitely. Maybe also the newer version. I think there was a revision that is pin compatible with the ESP8266. That's also interesting. And if I could, I would love to use a Raspberry Pi Pico. I just ripped out the box of microcontrollers, so I've got a bunch of them here. Oops, I love those things. I really love them, especially the programmable I/O part of these. It's really amazing, and I think they could help a lot in communicating with the Game Boy. Of course, I wouldn't use the development board. I would use the chip itself. That's no problem. They are available for, I think, $1 a piece, something like that. Problem is they don't have a Wi-Fi module, so I would still have to pair it with a ESP, and problem then is I would use even more, I would consume even more power. You even would need a higher current, or at least I would have to manage it really well that it doesn't boot up at the same time or something like this, and then it doesn't help that much anymore to have the Raspberry Pi Pico in there. So yeah, I would have loved to be able to use this for the project. At least in hindsight, when I started designing this, I had no idea. I just used the microcontroller I still had in the drawer. But If I could pick this one, I would have loved to use it, but it doesn't have Wi-Fi, so I would have to pair it with another one. Also, all the boards that are available, the Raspberry Pi Pico or the RP2040, that's a chip on there that is the Pico pretty much. There are, from other vendors, there are combinations that have a Wi-Fi module on there. Usually the Wi-Fi module is just an ESP32, so there are usually also devices that pairs of the RP2040 and an ESP module. So that doesn't help either if someone is thinking in this direction. So yeah, the answer is I think I would have used an ESP32, but no idea where this would have led in the end. I mean, so many people, I mentioned in the video that this is a modern microcontroller. It depends on what you compare it to. Compared to the Game Boy, it's a modern microcontroller. This thing is not the newest thing anymore, and it's not probably the best idea to base a new project on this unless you have still a few around. So they're not really outdated in that sense, but they're not the newest ones. Okay. Do you also consider using FPGA as cheating? No. That's fine. I want to try an FPGA at some point. I'm not sure which project would be suitable for an FPGA, but no, that's not cheating. Why should it be? I mean, yeah. What did I mention before? What I consider cheating? Putting a battery in there was what I no, that wasn't what I considered cheating. I'm not sure in which context I mentioned something about cheating, but I think FPGA is an interesting thing and might be also very helpful there. Yeah, I've never used one. I cannot really say much about advantages or disadvantages, but an FPGA would be a very interesting thing, although they're quite expensive, I think, for such a component. Yeah. It's also an old comment. I'm behind almost an hour now. Not buying parts from China. Is it Germany politic? It's EU politics, I would say. Okay, now that you ask, I should probably not have used this question. What I mentioned before is that as my main job, I work at a German university, so I'm a public servant. I'm using public money when I buy stuff there for my research or for the stuff I develop there. And if you use the public money, so taxpayers' money, you have to obey to a few rules, and it's not prohibited to buy something from China, but you have to document and make sure that they obey a bunch of rules that manufacturers within the EU have to obey anyway. So also I want to say, many people talk about buying stuff from China like it's something bad. I don't think so. I mean, in the end, if you're buying an iPhone, that has been manufactured in China, most of it, yeah? So that's not about being cheap stuff or policy against China. It's more like protecting the rules of the EU. So in the EU, there are a lot of rules of protection for workers, for the employees. There are a lot of rules about environmental protection. Of course, there are taxes, a tax that has to be paid by manufacturers within the EU, and it doesn't make sense to have these rules if just beyond the border, I mean, China's not directly behind the border, but if you can just move your company beyond the border and then just sell it back into the EU without obeying these rules. That's why there are things like customs and all these rules. So that's why it's so easy to buy stuff within the EU and switch everything, because they all have common rules. But if you go outside, then you have to make sure that these rules are still applied for it to be a fair competition. And in this public sector, it's a lot of bureaucracy. You have to fill out a bunch of forms. You have to prove that they do certain things, and then on the other hand, most Chinese manufacturers then say, well, why should I care for this one university order? I'm not doing this. I think it would be possible. It's just much easier to buy from the EU, because you do not have to do much of the paperwork, because it's immediately proven, because they're a company within the EU, that they have to obey the rules that the taxpayer agreed on through politics that they should have for companies. Okay, so I hope this is a good way to put this. I do not want to make this about politics, and I do not think that it's I think it makes sense in a certain way, but it's quite annoying if you want to do something. How long is the latency when streaming? Not sure, this comment is almost an hour ago. If you weren't there at the beginning, check out the GTA 5 stream I did in the beginning on the Game Boy Color. I think there was one part where I demonstrated pushing left to turn a car and you get an idea. So it's not good, but most of this is probably encoding of the, it's just a stream. I mean, I'm streaming from a PlayStation because I do not have the desktop version of GTA. I'm grabbing, so I'm streaming from the PlayStation to the laptop. Then I'm grabbing the image from the screen, process it through FFmpeg, which I did not optimize for low latency. And then I process the output through Python script, and then I push it to the Game Boy. So I think most of the latency is not from the cartridge itself, but from the stuff going on before that. It could be optimized. But then once again, this is not a practical build. I do not recommend actually playing GTA on it. It's more demonstration. So I think latency is not that relevant, I think. By the way, if you're thinking about creating a game that uses these streaming tactics, on one hand, there's this, I found this, someone brought to my attention, there's this Game Boy video player for the Game Boy Color, which might be a better resource for this, but if you want to adapt this stuff for the original Game Boy, because I haven't seen it on this before, and maybe want to pair it with some flash memory or something like this, I think you can get the latency as low as you want. So that's not an issue of the technique of getting the video into onto the screen, if that's where this is going. If I'm using double speed on the Game Boy Color, that's why it's actually so easy. I was starting, or maybe I mentioned this before when someone asked about the Game Boy Advance. I think getting the video stream onto the hardware is easier with each newer device, and for the Game Boy Color it was very easy because it can run the same code as the original Game Boy. The only difference pretty much is, let's get the picture nicer. The only difference is that the Game Boy Color has a few additional registers to define colors and very few extras, like for example DMA transfer for the VRAM, which I do not use because my cartridge uses a fixed address to communicate, so that doesn't work with DMA. But besides that, the main feature of the Game Boy Color is that it has a double speed mode, and it runs the same way as the original Game Boy Color, Game Boy, just twice as fast. So if you followed what I explained in the GTA 5 video, where I explained how to draw an image on screen, I can easily achieve 30 FPS. I didn't look at 30 FPS, I think, because of the screen grabbing before, but theoretically I could achieve 30 FPS easily because I can get twice as much data during H blank or V blank, so these parts where I can access the VRAM. So when I can actually transfer the data, and just runs twice as fast, so it's really easy to rearrange that. And then, I need 64 bytes for the 8 color palettes and 1 additional byte per tile to define which color palette is being used. And that's really easy to get in there. So it was much easier to get it to work on the Game Boy Color than on the original Game Boy. Of course, also because I already had done it for this and only had to adapt it. But it's using double speed because, why not? The reason not to use double speed on a regular game might be increased battery, to increase battery life, because it consumes a bit more power, but battery life is out of question with this contraption anyway, so that's not a reason to not use it. Next one. I try to look into the chat sometimes. Few people are asking about re-uploading this. I think it will stay online at the end, doesn't it? I hope so, because I'm not recording this, but I think YouTube keeps this available. I do not think that they just drop it, right? It would be a pity. Okay. Have you looked into Wi-Fi chips that need less power, or maybe downclocking the one you use for better efficiency? No idea. I haven't looked into this. I haven't even looked into the power consumption of this one before I built this thing, and I just was lucky that it was just enough to power the thing. No idea. Might be worth looking into. Yes. Next one. Any thoughts on the feasibility of making a universal game cartridge out of an FPGA? That's an interesting thing in many regards. First of all, many people asked if this could be used to stream ROMs onto the Game Boy. The thing is not this cartridge in particular, because I can only control 2 addresses. The rest is in the static EEPROM, and I can not program it from the ESP. In theory, you could build something where the ESP can program the EEPROM, or maybe some different kind of flash memory, or maybe FRAM or something like that, which would be a better solution for this probably. So then you could, in theory, download a ROM and write it into the EEPROM, but the problem is this only works for the very small cartridges that use 32 kilobytes. So like Tetris would work with this, but not the larger games, because what the Game Boy does is it has a fixed memory space for the ROM of these 32 kilobytes, and anything beyond that, if you read somewhere that some cartridges or some ROMs are 2 megabytes or something like this, is that they have a memory bank controller, and there are, I think, 4 or 5 different memory controllers that are common. Not sure. Look into the sources from the Game Boy development community. This is all over the place, this information. There are certain memory bank controllers that are common in commercial Game Boy games, and you need to emulate them if you want to get the ROM to work on your cartridge. So it's not as easy as just allowing the ESP to write to the EEPROM. You need to add more logic to it. And yes, an FPGA is probably a very good way to emulate this. And yeah, I'm guessing here, but maybe someone has looked into this. An interesting thing is, if you know this analog pocket, they are advertising that everything is running from an FPGA. That's why their hardware is closer to the original. Not too sure if it's that necessary, but that's the reason that this is one of the few devices where you can actually use Game Boy camera, for example, to run the games on it. It doesn't look good on camera if it's just black with this lighting that I have, so let's turn it on. But they're also advertising that they have 2 FPGAs in there. I haven't looked into this, but one thing I thought about is whether they plan on using the second FPGA to also emulate a ROM. They're not doing this officially, because officially they say this only works with the cartridges, so I'm not sure if they could get into trouble to support ROMs officially, but others do this as well, or it's just an image thing. So the image of the company that they want to provide. But I'm wondering if the second FPGA is just for their menus, or if they need this to emulate the Game Boy, or if they actually build it into this to be able to emulate the cartridges as well. But yeah, they are emulating the entire Game Boy with an FPGA. Emulating a memory bank controller should not be too hard. So I think that should be possible, but I haven't looked too much into it. Okay, next one. Okay, have you looked at the later generation cartridge tech that's similar to the Game Boy Advance question before? If so, are there any features that pique your interest? I haven't looked into those yet. I have to admit that I'm mostly interested, at first I was mostly interested in the consoles from my childhood, which is the original Game Boy, and the Super Nintendo would be interesting. But yeah, I haven't so far. Maybe I will. How do you pick your creativity, think of cool ideas to work on? Not sure that these ideas just pop up. In this case, this idea came when I found the old Game Boy again on the attic from my parents' attic. I was looking for something else, an old toy for my son that I wanted to find, but I found the Game Boy. I didn't even know that I still had it, and I was curious about the cartridges. Nothing, I cannot say how I came up with this or with other ideas. How expensive is such a Game Boy with Wi-Fi? Actually, the cartridge with Wi-Fi. I think that's what you meant. Not sure. I'm not sure if I did the calculation on the block entry. I think the shopping cart for the components was around 50 euros or something like that, I think. And the most expensive part is unfortunately the EEPROM. That's the reason why I shouldn't have used an EEPROM. Those are mostly old components that are not in use anymore, so they are mostly expensive because they are so retro, I think, at least. I'm not an expert on this. You could save a few bucks by... oh no, you couldn't. I think this large... Tantal capacitor was quite expensive, and this one is unfortunately not available right now. You can probably replace this with a cheaper one, but yeah, I have to look into this. So I think around $50 for the components, and then the PCB. I think the ones I ordered from GLC PCB were, I think actually again $20. The reason for this is that you have to look for the finish, because if you get the cheap finish, then the contacts will wear out quite quickly if you push it into the Game Boy in and out. But that's, I think, about the order of magnitude that it would cost. Probably if you know where to get your components, you can get it cheaper. But yeah, it's not the most expensive thing. What would you recommend to total noobs who would like to make a project for Game Boy but do know anything about hardware and electronics? Yeah, if you just want to do something for the Game Boy, you probably should not start with hardware if hardware is not your thing. I would recommend getting just basic. If you want to run on the original hardware, you should just get a basic cartridge where everything is mapped to a simple EEPROM, or maybe a flash cartridge. I think that's also fine to work on a cartridge that emulates these basic cartridges. But I think the best point to start and the easiest point to start is with an emulator. It depends on what background in coding you have. If you want to just get something running, the Game Boy Development Kit 2020, it's linked somewhere in the first blog entry because that's what I use for the Wikipedia example. It's very easy to use if you have some C knowledge, and you can just run the created ROMs in an emulator. That's true for pretty much anything you do anyways. Downside of this is these high-level functions in C do not work well on a Game Boy performance-wise. So it's nice to get some text onto the screen, and with few lines of code you can do something like this Wikipedia example that I did. Problem is they also explain in the documentation, that's the part I like to quote, that you should be careful about division, modular operator, and multiplication, because that's hard to do on a Game Boy. And if you eventually look into the actual instructions that are available on the CPU, you understand why. So, oh no, that wasn't a good idea. So it's quite limited what can be done with this higher language. If you really want to create a game, you probably don't get around to look into some assembly. But again, if you just want to write some code for the Game Boy, I would skip the electronics and first work with an emulator. And if you eventually want to do this on an actual Game Boy, get one of those cartridges where you can simply upload your ROM to it. Or if you really want to have a cheap, simple, actual cartridge with a real ROM or EEPROM on this, there is I think by someone who has Gecko in his name. Let's see if I can find this. Here's a bunch of PCBs for... how do I find this quickly? It's in my first blog post. I'm quite sure that I quoted him there because I used this PCB design as a base for the outline and the connector of my cartridge. Is it on GitHub? Come on! I should easily find this link because that's because at least I have to give it credit in the PCB design. GPIO is the name. So should I just push it into the chat? Maybe that's a good idea. So let's post it into the chat. That's a GitHub repository by someone who is called GPIO, or whose nickname is GPIO. And if you scroll down there, I can also share this on the screen. I think you should see it now. It's again the same screen where I've got OBS running. That's always a good idea. So you see it's got a bunch of cartridges. And if you really want to start with a cartridge that you also built yourself, there's one cartridge. Where is it? This one, the Cart32KA should be the one. Yeah, that's also one I show in the video. You see it's quite minimalistic. And if you look into the actual layout, I think that's a great way to start. And you have a PDF or an image screen in there. Schematic. There it is. Okay. That's one I also showed in the first video. It's just EEPROM or PROM connected directly to pretty much all of the pins. Yeah, with a resistor to permanently set it to what is this for? to pull up the right pin for the ROM, so you can only read from the ROM, which makes sense for this type of cartridges. And I think he has some capacitors, yeah, over here to stabilize this thing, but you only should use one of those. Should be plenty for most things. So this is a very basic cartridge. It only has 32 kilobytes, but that's a great way to get your first project onto a real cartridge, I think. But I think you can also buy this type of cartridge somewhere. I think I've seen this also somewhere. Okay, back to this screen. And now I need my preview again. Oh, no, that screen. Okay. Next one. I'm quite happy that this Python script to get the questions is working so well, I have to say. But I just whipped it up yesterday. Thought it would break. Yeah. Do you think this would work in Super Game Boy on the SNES? I think so. As far as I know, these are identical to an original Game Boy. I'm not sure if there was some issue if they run at a slightly different frame rate. Then you might have to adjust some of the timing of the code. Not entirely sure, but then the instructions should also run a bit faster. But in principle, I would expect so. It also worked pretty much directly on the Analog Pocket. But there were also some minor timing issues, although the guys from Analog contacted me and told me that there's an update coming soon, which probably fixes this difference from the original Game Boy. And for the Super Game Boy, I would expect to work similarly. Unless it has a problem with this higher power consumption, but I think for the Super Game Boy it should be less of a problem. And yeah, as I said, maybe a little timing issue that might have to be adapted, but I also wouldn't even expect this one. It's an interesting one. Do you have plans to add GPIO to the card so you could add more buttons, for example, like a controller port? That's actually an interesting thing to do. As I said, I don't think I wouldn't do a next version for this cartridge, but one problem is that right now I'm using all the GPIO ports of the ESP already. But if you get another microcontroller in there, or some multiplexer, or some shift register, this should be easy and possible. So yeah, it's a quite interesting idea. I mean, also be quite interesting. Maybe not on the original Game Boy, but okay, but also not on the Game Boy Color. So I mean, you can place some buttons over here, so like some shoulder buttons. I think the newer ones had this. The Game Boy, the Analog Pocket has shoulder buttons over here. Could be on the cartridge. Might be interesting. Yes. Okay, how expensive? That has already been asked, so I can skip those. How much did it cost to make this? We already had that. I start to catch up. To the future of... Okay, this is an interesting question, but I'm not sure if I can answer it, but I want to share it with you. Do you think this is analogous to the future of mankind, where humans will augment themselves to artificial superintelligence that will communicate with the biological cerebral cortex? Yeah, sure. That's like the Matrix, retrofitting the old CPU of humans with a more modern one to stream more interesting images into your head. So that's what you're going for. Why didn't you use an ESP32 instead of an 8266? Yeah, that we had that because that's the one I had around. Sorry, I think I would use ESP32 in the future. Could you do something similar with a regular flash cartridge, mainly the video part? I know you wouldn't be able to use Wi-Fi. Yes, depends on what you think of as a regular flash cartridge. But at least for the Game Boy Color, I mentioned several times there is this Game Boy video player. I haven't tried it, but I think this should run from pretty much anything. The main reason that you did not see this from the that you haven't seen full motion video in most of the original games is probably simply because the memory was so limited. If you have a flash cartridge, I think it should work. There is a little difference. One advantage, at least on the original Game Boy for my cartridge, is that all the bytes are read from the same memory address. That's better because if you look at the assembly code, you actually need 3 instructions to copy from one memory point to another one, because you have to increment the source address all the time. And if it's the same source address, it's a little bit faster. That's not entirely true, because I also learned about a technique called pop slide, where you use the stack that's usually used for function calls to read the memory faster, and this uses 4.5 memory cycles per byte, but still the version of my cartridge where you're reading from the same memory address uses 4 cycles per byte. So the code for the original Game Boy would run a little bit slower on a flash cartridge because you cannot read different bytes from the same memory address. But I think you should still get close to this, what I showed on the original Game Boy. And on the Game Boy Color, yeah, you've got more headroom. And as I said, there's a video player project for this. Not sure if there's some other limitation that you hit eventually, but if you've got plenty of memory, like in a flash cartridge, I think it should be doable, yes. Okay, how much do aesthetics play a role in your projects? Do you have any personal design principles you tend to use? Not really. No, I mean, at some point I try to, in the video, I do my best to make it look nice, but there's also a limit to how much time I spend on making it look right. I mean, if you watched my videos, I have a bad habit of not thinking about fixing cleaning the stuff before showing it on camera. So there's a lot of dust in these projects. That probably tells you how much effort goes into this part. I try to get better in this, but yeah, presentation is what takes some time when I'm doing the videos, but yeah, I try to make it look nice as far as I can, but there are no design principles. Interesting thing is, okay, I see some colleagues posting stuff in, some colleagues from work posting stuff in the chat that distracted me right now, but hi Dominic. Okay, yeah, this pretty much it's pretty much answered several times or indirectly, but yeah, as the question pops up, it's a fast one. The image was pre-processed in the PC after sent to cartridge, or ESP realized all processing. No, the processing was done in ESP on the PC. The ESP mostly just takes the bytes and shoves them over to the Game Boy as they are. So the ESP doesn't do much more than taking the data and then giving it to the Game Boy when the Game Boy asks for the data. Something that is on top of this question a little bit, I thought at some point if it would be interesting to have some more common video format that could be processed by the ESP, but I don't think that the ESP has the headroom to do this. Maybe if you've got something like an ESP32 and you can use a second core, but we already have a list of things to do on the second core by now, this might be possible. Maybe a faster microcontroller could actually get some low resolution but standard format stream to do this. But then you would also probably need more. You would probably also need more power in there. So yeah, right now it's processed on the PC, and the cartridge just takes the image and dumps it to the Game Boy. Okay, interesting question. I know where you're coming from. The question is, it's already on screen here. What's the most modern game console that could be emulated by hardware that would fit into the Game Boy, and so doing emulation on the Game Boy itself? I have no idea. I think if you do not use Wi-Fi, you have got a lot of options, maybe a lot more than you would expect. I think something like the RP2040, so this Raspberry Pi Pico, could do a lot, because it doesn't have to really. If I'm right, I haven't tried it, so that's often if you hypothesize about these things and you try it, you hit some other problem. But if you can use the the programmable I/O ports of the Raspberry Pi Pico, I think it doesn't have to care about the communication with the Game Boy. Not at all, but not too much actually. At least it's buffering then the communication nicely. And the Raspberry Pi Pico already has a lot of is very modern or new microcontroller, and I think it has decent speed and not too much power consumption. But the power consumption is not that much of a problem if you don't have a Wi-Fi module. So I think you can pick several faster microcontrollers if you do not use Wi-Fi, if you want to emulate on the Game Boy. That's actually quite an interesting project, quite tempting one to do. Not sure if you could do I have no idea how much power you would need for an emulator like that, but that's an interesting thing to try, and I think you can get quite far if you do this, but I do not want to guess about the console that you actually can get to work, but it would be an interesting thing to do. So maybe for those who want to create something like this, I think, so there were a lot of people creating Wi-Fi for the Game Boy. I know what's his name? Come on, Jesse Doherty was really on my heels. So I think I beat him to the Wi-Fi a little bit, but then he technically at least got to stream Doom before me, only at 1 FPS or something like that, but he was faster than me. And there were a lot of other projects in this direction, and a lot of people told me, yeah, I tried this some while ago, but I gave up. I think the problem most projects had, not by Jesse, I think his just wasn't finished yet. He didn't have a cartridge, but had this on a breadboard. But many of the projects that failed made the mistake that they wanted to emulate all the communication on the microcontroller. There are actually 2 projects that managed to do this, also one with the Raspberry Pi Pico and one with the, not sure which one, another faster microcontroller. I linked them also in the first video if you are interested, but I think that's not the best way if you want to do something more on the microcontroller, because the microcontroller is dealing with communicating with the Game Boy quite a lot. And if you take the approach from my design, maybe combine it with some even newer, better ideas in electronics, so the idea to map only one address or a small address range, maybe it's for DMA it's a good idea to map more than one address to the microcontroller and do the rest from static memory. I think this would be quite a feasible project, and the result would be quite showy is not the right word. I'm looking for the right word now. It would look cool. That's a good way to put it. So yeah, would like to see this, but it's not the next thing I would pick up. So, but if no one does it within a year, maybe I will do this. Not sure. It's an interesting idea. Yeah. The question has been around a lot, and that's a little bit annoying. Will you make a version that will support audio using the audio pin on the cartridge in the future? That's a little bit, that's a little bit embarrassing, because in the first video I said, yeah, there's this weird audio pin, but we don't need this. I didn't think of video streaming at that point. I didn't see a point in this. It shouldn't be too hard to do this, but as I said, I really want to finish this project at this point, but it shouldn't be too hard. I don't think that you just want to hook up one other pin to this port, because then you have to bit crush the entire thing on the microcontroller. And a simple chip that can play a few things in between should be a good option there. At least I haven't looked into it, but I think it shouldn't be too hard. But I'm not doing this. I think I will leave the project at the point where it is, because there's so many little details that you can add that I can spend an entire year. But I would only would do Game Boy stuff for another year if I want to optimize it to perfection. It's a hobby. Okay, so there's a point where I have to say, okay, it's good enough. You mentioned you wouldn't use an EEPROM if you did it again. What would you do instead? I think I would use flash memory. It's cheap and it's available. I have to admit, I haven't looked into how to translate it to flash memory. There's a huge difference in the way they communicate. The EEPROM, I picked the EEPROM because that was the easiest thing I could find that does the parallel memory bus. If you remember the first video, the EEPROM has these 8 data pins and 16 pins for the address, and it's a very simple format. You set the address with the 16 pins, give a clock signal and information if you want to read or write, and then the 8 data pins have this byte and send it forth and back. Modern flash memory doesn't work like this. If you look at an SD card, I have one to show. You all know what an SD card looks like, but it's always helpful to hold something to the camera to prove a point. This one has much more memory. I just bought one with 256 gigabytes, and that wasn't the largest one, but an economically reasonable thing to record 4K. And these things have way fewer pins than the EEPROM does, and that's because they use serial communication. I haven't looked into how this exactly works, but you need an additional chip or maybe you could do this in FPGA, but I think there's something more efficient and dedicated for this. I think so. I haven't looked into this, but you cannot hook up this thing or flash memory that comes as an actual IC or some other electronics component. You cannot directly hook it up to the cartridge of the Game Boy. It doesn't communicate the same way. The EEPROM is technically, you saw this PCB that I showed, 10 minutes ago, half an hour ago, I'm not sure how fast we're going through time here, where the ROM memory is just hooked up to the cartridge pins, and the only thing that this guy added was a resistor to keep the write pin on the level that it's actually only reading from the EEPROM, and one capacitor to deal with voltage noise. What is the name? I'm starting to have a hard time finding words right now. But so the EEPROM is much easier to build into this. But I think there are also modern memory modules that also emulate this communication style. I'm not sure. I haven't looked too much into this. But yeah, the main reason is the EEPROMs are quite expensive for what amount of memory they deliver. And flash memory is so cheap and so available today. The only problem is you have to convert between the serial communication they do to the parallel memory bus of the Game Boy. And that's why when I designed this project, and in the beginning when I didn't have much experience in doing this, it was the easiest choice. But it's not the cheapest or most economical one. Okay. So how do we manage to be smart and handsome? Thanks. I do not think that it has to be. I'm not sure how to answer this, but thanks. Yeah. Any ideas to use the infrared capability of the Game Boy Color to other applications? I have to admit, I didn't even know that this thing has an infrared port before someone mentioned it in the comments, and a week ago it's the first time I had this in my hand. I'm not sure if I want to do something with this. It's interesting that this is available, but there are a few gimmicky things that could be done with this. But even controlling TVs, that would have been fun to have a cartridge to control TV back when this was a new device. But today, I mean, it's. I don't want to argue with practical things because the things I just built here are not practical anyway. So this is just for fun. Yeah, but you can have a simple infrared transmitter with very few components on any Arduino. It's cool to do this on a Game Boy, but I have a cartridge that can control pretty much anything in my home through Wi-Fi if I want to. So controlling something with the IR port, it's not that appealing, I think. It's very specific. Might be an interesting project, but I don't think that I would do something like this. Have you made the PCB files available on GitHub? Yes, so this may be a good time to announce it again. So on all my videos, there's this link to my blog, there ought to be, so there.orte.be for this actually Belgian top-level domain, just match the name, is the actual URL for my blog, and there's a blog entry for so the first blog entry is probably more interesting for this one. There's a link to GitHub where the PCB files are, where all the source code is, and everything is open source and open hardware. Do you think in the reverse process, I mean, to send the image of a Game Boy to stream out? I think something of this has been done. I think I've seen this somewhere. The thing is, you will not be able to do this through a cartridge. I mean, what you're thinking of is playing an original game or some dedicated game and getting it out through the cartridge. I mean, you could do something like a Game Genie, so put it between the cartridge, but the Game Boy is not sending out the image, so you would have to emulate the Game Boy on the cartridge in between or something like that. You can actually see most of the communication that the CPU of the Game Boy does on the memory bus, so maybe that helps to capture these things, but it's not like you can get the original image out of there, so at least you need to emulate the pixel processing unit to create the image and then send it out if you want to do it to the cartridge port. But I think I've seen some modifications of the Game Boy that can do this. I mean, if you want to stream Game Boy games, and I think the truest thing besides using an emulator. The truest thing to do this on original hardware would be a Super Game Boy. I think that would be the best option. I don't think that there's a really reasonable way to do this as a cartridge, if that's what you're aiming at. Besides that, yeah, there are hardware modifications, and there's the Game Boy, there's a Super Game Boy. Yeah. What inspired you to do this project? I think, yeah, we had this more or less. Okay, so let's skip this one. Yeah, maybe could go into more detail about this one. What's the issue with the power supply? Is it just a matter of adding some capacitors, or is a redesign of the layout needed? That's an interesting question. I mentioned several times I would love to hear the opinion of someone with more experience in electronics. I'm not an electrical engineer. One problem definitely for the Game Boy Color is, I mean, it's on the back side and in the image all the time right now, is that it's rated for 300 milliamps at 3 volt. And what's happening inside is these 200 milliamps are for the entire Game Boy system, and internally it's stepping it up to 5 volts because the cartridges from the original Game Boy expect 5 volt, and the Game Boy Color does the same thing. And I'm stepping it down again to 3.3 volts. With a nice voltage regulator, not just a voltage divider, of course, but it's all a lossy thing. And in the end, the ESP easily draws 200 milliamps when it is working heavily, like when it's just established a connection. And yeah, it's all a little bit much for the Game Boy. I think since the high current only occurs occasionally, adding more and bigger capacitors will certainly mitigate the problem. That's why in contrast to the first design, I added this big capacitor over here. But at some point it gets a little bit ridiculous to plaster the entire thing just with capacitors. I think at some point that's not a good design choice, and I'm not sure how much it can help. But maybe it's enough to get rid of this spike. I mean, you have maybe seen what it does in the original Game Boy when at the end of the first video. This doesn't glitch out, but maybe we can see it right away now. Yeah, you see this? It almost always garbles the, it's hard to see, it garbles the boot up screen. Besides that, it's working, yeah, but almost every time I turn it on, it looks like this. Okay, so I'm not sure if it comes out, is the light bright enough? Hard to see. But there's a lot of glitches on the screen when you just turn it on from the power spike, and it's really close to what it can do. Maybe they're more efficient Wi-Fi chips. Maybe I'm not sure if the ESP is capable of reducing the transmission power. That might be an interesting thing I haven't even thought about. Maybe we can reduce the power consumption of the ESP a little bit. Yeah, but it would be interesting to hear from someone who's a little bit more experienced with electronics, or maybe the ESP. Yeah, so that's something I mentioned when I did the when I explained how I pick the colors. Is it possible to change the palettes per scan line? Yes, that's possible. So on the Game Boy Color, you can change the palette during H blank. You can substitute 2 color palettes, so in total 8 colors per H blank. So for each scan line, you can replace 2 colors. It's still a little bit limited what you can do, but you can. Someone mentioned in the comments that there is a way to get almost 2,000 or more than 2,000 colors onto the screen. There was some project. I haven't looked it up, but to my calculations, that makes sense. That's possible, yeah. But interestingly, as you mentioned, the NES, there's also a project where someone streams video onto the NES. He calls this reverse emulation. Several people mentioned this, and it's a very interesting video to look this up. Maybe I should also put it into chat for those who are interested. Although if you promise to not leave right now, but at the end of the stream. NES reverse emulation. I think I should find it right away, and you don't have to wait too long. Yeah, there it is. I copied the address, and where is my browser window where I control the stream? There it is. Too many screens here. Okay, so this video, please save it as do not leave. If I now see all the all viewers leaving, that would be quite annoying. Yeah, but yeah, if you want to go ahead. This guy does pretty much the same thing on the NES, but the interesting thing is that the NES is quite different. if you look what this guy does is he doesn't have to worry about transferring data only during v blank or h blank, so at the time when you can access VRAM, because the VRAM is not on the NES itself, but it's also on the cartridge. So the more difficult thing about the NES is that you deal with two memory buses in a certain sense. So you have to provide the the communication for the main memory for the CPU, and you have to provide the communication for VRAM. But the advantage of the NES then is that if you also emulate the VRAM communication with a microcontroller, that's I think what this guy does, you can deliver anything from VRAM at any time you want to. So you do not have to worry about at which time the Game Boy allows you to write to VRAM, because you are VRAM in a certain sense. So yeah, in a certain sense easier, in another sense maybe a little bit harder on the microprocessor. So it's interesting this comparison, and I can really recommend this video. It has been recommended to me. It's much older than my project, and it's quite an interesting one. How long did it take to? Okay, how long did it take to create the cartridge? We had this at the beginning. So yeah, for those who missed the beginning, and when I mentioned we had this earlier, I will later add chapters to it if the stream remains available. Some people asked about this, so this makes me a bit skeptical, but I think it stays available. Could you please not stop this project, please, because there's no active Game Boy development community really, and this is the most exciting thing Game Boy related in years. I think it has picked up recently, hasn't it? I've seen, maybe it's just my bubble because I started searching for Game Boy stuff to see who is reporting my project, but I've seen quite a few interesting Game Boy things recently, and maybe it's picking up again with this example. Maybe someone starts from there. I'm not leaving it forever, but I do not want to become a sole Game Boy developer thing. So I will probably return to something like this, but I also don't have the impression that nobody is really interested in this. Maybe it's picking up from this point. At least I hope so, if it's really not that much development going on there. But also maybe the Analog Pocket also had made quite a wave, I had the impression. Or maybe it's also just my perspective because it came out when I started looking into retro stuff, but I had the impression that quite a few people are looking into what can be done with this besides playing games. But yeah. Moinsen, what if you streamed a Game Boy emulator from your PC? Yeah, I did a short example of streaming Super Mario in the GTA video. This works quite well depending on what you do. I mean, still no really point to it. There are nice handheld devices that can emulate directly on the device itself. But something like Super Nintendo works quite good if you do not need all. Actually, there are 4 additional buttons. There are shoulder buttons and 2 more X and Y. If you don't need those, it works okay if the image doesn't require the higher resolution. And of course, oh yeah, you're asking specifically about the Game Boy emulator. Yeah, I haven't tried this, but this should work fine. Maybe the delay is a little bit annoying, and the fact that the whole thing is always just a minute from glitching out because of the power problems or because of some timing issues. So, but yeah, should be not too hard to do. Actually, when I started this stream, I thought of doing a bunch of demos, but there are so many questions. I think I will not demo this right now because I think we can all imagine what it would look like. But I think I will go through the questions because there's so many. Sorry. I think this is similar to the previous one. If I could use HDMI on a Game Boy or Game Boy Color, I mentioned this before, if I could stream out from the Game Boy, you cannot, I think you cannot do this through the cartridge port. Yeah, okay, I'm answering, so I show the question. But I think you cannot do this through the cartridge port, but you have to modify the Game Boy itself. And I think I've seen projects like this. Question's not popping up. I should probably restart this part, so it would. Okay, yeah, just for reference. But I think it's mostly the same answer as before. Do you have any end goals you're hoping to learn or produce pertaining to the GBA hardware or architecture? No, there wasn't a particular goal to this. I wanted to figure out how the cartridge works, and from there it just escalated until I was able to stream video. This wasn't the intention from the beginning, and yeah, as I said, I think I will pause at this point because this can just escalate further and further, but I might come back. That's actually an interesting one. How do you deal with focusing on your job when at work and not on the things you want to do after work? Again, the question's not popping up right away. That's a little bit annoying, but it should come on soon. There it is. I think the trick is that I enjoy my job as well. I mean, of course, yeah, there's sometimes some parts of so yeah, maybe at this point I should explain what I do as a job. So I'm a physicist and I work at the RWTH Aachen University, and I'm the developer of an app for physics education called VFox. Maybe someone has heard of it. It's an app that uses the sensors in your phone, like the accelerometer, magnetometer, and stuff like this, to do physics experiments, which is mostly used for teaching. So you can do physics experiments with your phone. And that's not much different from doing this kind of stuff. It's a lot. Yeah, I enjoy my job also a lot. Of course, in this job, there are a lot of additional stuff that's not this electronic stuff, like writing publications, doing applications for projects to get fundings for what you do, and also as a university, there are a bunch of students who you have to look after. I have to do some teaching. I have to look into the thesis of PhD students, master students, and stuff like this. So there's a lot of stuff around. There's a lot of bureaucracy and a lot of things just to keep this thing going. But the basic thing, the main thing of my job is not that far from this, and it's also quite exciting. So you have to help a lot if you like your job. So maybe not the answer that you're looking for, but but I have to admit, sometimes and when you really have, if you went to sleep the other evening and didn't fix a problem, and in the morning the solution pops into your head, it's really hard to concentrate on other things than just moving over to your other project and try out the solution. So I have to admit it's not that easy all the time. Yeah, but yeah, I mean, it's a job, you have to do it then. So yeah. Okay. Okay, that's a very electronics question. I have to admit, I'm not entirely sure if I can really answer this. If you considered using step-down DC-DC converter to convert 5 volt to 3.3 volt, it should convert over 90% of the energy instead of dissipating it in case of simple regulator. I have to admit, I'm not even sure if I'm using the right words when I describe what I'm using there. I'm not even sure what I'm using right now. As I said, I'm not an electronics guy. I looked for something that converts the voltage from 5 volt to 3.3 volt. I have to admit, the converter or regulator, I'm not sure which it is, on the original design is just the same one that the Node MCU uses for the same ESP module. That's because at some point I realized I have not much knowledge about how to convert the voltage, and so I simply looked up what they used and picked this for the project. And for the new revisions, new ones I want to buy, I looked for converter or regulator that has a lower dropout voltage, so in the hopes that I can get away with lower battery voltage. Although I'm not sure if this is really the problem, because the voltage that the Game Boy provides to the cartridge doesn't really drop down unless you draw some current, so maybe it's not the dropout voltage is the problem. But I have to admit, so if you know about these things, would be nice if you could look into what I'm using there and send me a message telling me if there would be a better alternative, because I do not have much electronics knowledge there. I mostly just search for parts that seem that should fit, and this is the kind of stuff that I'm learning from these projects, and so some feedback would be nice. When were you born? 84. So I have to calculate. So this year I didn't have my birthday yet, so I'm 37. Is that right? I think so. Old enough that I have to think about my age. So I'm from 1984. Yeah. So by the way, so if you're asking, I did not get a Game Boy right when it was released, but the original Game Boy was the one Game Boy that you could get when I eventually got a Game Boy. So this one is the mobile console of my youth. Okay, again, question about Game Boy Advance. So we had this. Yeah, okay, let's quickly do this one. If I tested this with other devices that support Game Boy cartridges, Game Boy Pocket, I don't have one. Game Boy Advance, I also don't have one. I'm interested to see how similar their hardware is precisely. I think the Game Boy Pocket, somewhere I read that it's notorious for any kind of modding that for not being tolerant to high current draw. So I think the Game Boy Pocket will probably just brown out if you try it with this, just from what I've read. Don't have a Game Boy Advance and I don't have a Game Boy Pocket, so sorry, I didn't try it. If you're really interested in this, no. I thought about referring you to Tito from Macho Nacho, with whom I did a video and I sent him one of the cartridges, but he already sent this cartridge further. So, if at some point, one other YouTuber might try this cartridge. I'm not sure if this will work out or not, and don't want to mention someone, especially because I don't want to pressure someone into doing a video on this cartridge. If you see it somewhere else, maybe he or she has a Game Boy Pocket and can try it. Maybe they'll try it anyway, but I don't have one, so I cannot answer it, sorry. Okay, that's a complex question. I do not think if I understand it fully just by reading it on the side right now, because it's a bit hard to really concentrate on each word. So, this one card that uses the CPU for emulation on DS. So for fun, I'm working on shrinking a GBA onto a Game Boy cartridge, but I'm stuck on I/O bandwidth. In theory, could I piggyback on the DMG memory? I have to admit, I do not fully understand what you're trying to do there. No, sorry, I really don't get entirely what you try to do. I think that sounds like something you should probably just contact me on either on Reddit, Twitter, on one of those channels, and elaborate a little bit what you try to do, and maybe I can help you. But I don't think that I fully understand the question just quickly from the chat message. Okay, yeah, similar to the other one. If I tried on the Super Game Boy, no, I don't have one. That's so annoying. I sold my Super Nintendo, and I would have a Super Game Boy if I haven't sold it years ago. Actually, I also thought I had sold the Game Boy, so I was quite surprised when I found it back, a few months ago in my parents' attic. So otherwise, I wouldn't have done this. Because I thought I sold it along with all my other consoles, and I regret it so much that I sold this stuff. And I think at some point I will buy a Super Nintendo again, but I don't have a Game Boy to try it. Game Boy emulator, we had this one. Someone is testing my script by sending a lot of Q's with a colon. What if you streamed a Switch game to the Game Boy? Yeah, it would probably look similar to the GTA one. It would probably work, but it's probably unplayable, just like GTA. So it shouldn't be that much different if there's a way to hook up the Switch. But at least you could hook it up to. I don't have a Switch, but if it doesn't have a means to stream directly to a PC, you can hook it up with a HDMI grabber and should be able to stream it to the Game Boy. It might be harder to control it if there's not something like this PlayStation streaming function. But besides that, at least this playing should work. How did you get the attention in the press? I would wish you even more. Don't know. One aspect is of course that it shows the video title that I'm streaming GTA 5 on the Game Boy, not just generic. I could have called the video, not sure, just video streaming on the Game Boy. Maybe it would have led attraction there. I'm not sure if I would choose that title again. It's nice to have such an audience, but I have to admit, some of the audience that I got with this, the video wasn't made for them. Not because I do not want to show it to them, but I designed the video for the more techie audience because I explained so much about the stuff. And when the press got attention to this, and thanks to the title, of course, streaming GTA 5 to original Game Boy, got a bunch of people who just commented, well, he eventually starts playing at 8 minutes something, and who complained that I'm not just doing a Let's Play on the Game Boy, which wouldn't make much sense, but yeah, I try to get my videos to those people who are interested in this. I'm not trying to clickbait others into watching these. But I think this title, of course, helped, and at some point, the press found it, and then one of them reported on it. I think it also helped that this first video already was seen by a few more tech-related presses. Gizmodo, I think, was did one of the articles. I think at that point, some of these more tech-related news magazines or news pages saw already that I'm doing something interesting. Then I posted this example of streaming Star Wars on the Game Boy, which was pushed quite through the media. And I think many of them were already looking for what would come next because I mentioned that I'm doing a video on this. So I think from there it just went from itself by itself. Usually when I publish a project, the only people I inform about it are Hackaday, because most of my previous projects just fit well in there, and that's the page I also browse sometimes. But besides that, I didn't push it anywhere, and also the streaming thing didn't go to Hackaday because I was already posted about the Wi-Fi cartridge. So someone found it, and then they repeated it again and again, and yeah, some repeated it better than others, but it came by itself. Oh. Okay, is my script now glitching, or is it the same question? Okay, I hope it's not glitching, because then I would lose all the questions so far. Yeah, that's also something I thought about. What about a modern day Game Boy camera using ESP32 cam? Yeah, that's actually, it would be quite interesting project. I thought about this myself. I mean, in the end, this is mostly writing the Game Boy game part, the code for the Game Boy to show this stuff, and if you want to do a Game Boy camera, then you of course want to have a way to take a picture, modify it like you did it on the original Game Boy. You expect the Game Boy camera experience. So I think that's the most difficult part. I think so. I don't know. Okay, converting the image from the ESP cam to the format for the Game Boy is also a little bit of work. But I think the ESP32 should be able to handle it, and you can get the raw image there. You can get it at a quite low resolution. I think it should work. I mean, there's an interesting project where you do character recognition on the ESP32 cam to read the current state of your water flow meter and stuff like this, which, yeah, I have to Google for it. I cannot find the link right now. I'm using those. They take quite a time for the image recognition, and for this application it doesn't matter that much, but I think it should be doable. In the end, Nintendo was able to do it with this thing back at the time where nobody had a digital camera. So yeah, modern hardware, you should be able to do much more. Okay, GBA version, we had that. Okay, would be cool if you check out my Serial Boy project. I try to remember it later. I will not check it out right now. I'm not sure what I get there, but okay, I will try to remember this to check it out. Okay, yeah, that's the question that came several times, which I was looking for earlier. So what sort of educational experience have you had that gave you the skills to do these kinds of things? The fragments of this I mentioned throughout several questions. So I'm a physicist. That doesn't help too much with the exact skills that you need here, because as a physicist, you learn a lot of math, you learn a lot of basics of how pretty much anything works. I mean, if you consider the sciences, you can use physics to explain chemistry. You can use physics to explain what the electrical engineers do. And physics is more or less at the root of pretty much everything, but you don't learn much of the applicable stuff. So I learned what an ideal capacitor does. I learned what an ideal inductor does, an ideal resistor, so an ohmic resistor. When it comes to diode, I'm a solid state physicist actually, so I know very much about the details on the atomic scale, how an LED works. So I could explain how a laser LED works and stuff like that, but I would not be able to build a circuit to drive one. So the application isn't in there. So I did not learn these skills from there. Also coding, we have some basic coding courses that help us to mostly help us to analyze data with some Python code and stuff like that, but nothing too deep and no assembly or something like that, which you would need here. So yeah, being a physicist, but also having some similar education helps to grasp these concepts faster and easier, I think. It's much easier to read text that explains stuff like this and follow these tutorials. And I think if someone is really interested in this kind of stuff, more helpful, of course, would be becoming an electrical engineer, because then this electronics part should be an easy thing for you, but then you did not learn that much about coding. There will be some basic coding training in there, I think so, but not too much. Or IT-related stuff, so computer science or something like this. There may be some basic electronic stuff in there, but you learn all the coding. Well, yeah, most of the guys I know did not learn coding from there, but the principles about this, but that's a different story. But in the end, the correct answer for this, where I learned most of these skills, is by doing projects like this. I did not start by building Cartridge, but very early, already in school time, I enjoyed coding. And of course, if I pull out a project from back then, it's so much more basic. But the idea is that anytime you do a new project that's a little bit more than you could do at that time, you learn something. It shouldn't be too difficult, then you might fail, and that's not too much fun. But doing exactly what you can already do doesn't help you to learn anything. And one important recommendation for anyone who wants to learn stuff: do not just follow a tutorial by copying the code and running it on your Arduino and then say, yay, the LED is blinking, because you only learn something if you, at least I think you learn the most if you set yourself a challenge where you do not have the answer right away, but you have to figure it out yourself. So by all means, do an Arduino tutorial. When you got your LED blinking from the code that's in there, set yourself a challenge that goes beyond this. For example, add a second LED and make them blink at different frequencies. Actually, that's quite a difficult task if you come from this basic Arduino tutorial. But if you figure this out, you learn so much more than just copying the code. And I think that's where I learned most of the stuff, doing one project after another project, because I just like to do this. I mean, having fun doing things always helps in learning. Doing something that's just a little bit more than you could do before, because I learned so much from this project. But I think now I'm repeating something I answered earlier today. So let's move on. That's something that, not exactly what I thought, but could you use the link port and connect a keyboard and mouse to control the computer with? Yeah, that should be actually quite easy. The link port is just a serial port. Much slower, at least on the original Game Boy. The Game Boy Color has different modes for it. It can be much faster. You could not directly connect a modern keyboard to it, but you could do a very simple circuit to... maybe you could even connect it directly. I'm not entirely sure, but at least with a very simple circuit or just some microprocessor in between, you could easily send the input from a keyboard to the link port and use this in any game or anything. I would be surprised if there wasn't a project that did this already. Actually, there's a project that attaches Wi-Fi to the link port, and I mean, the bunch of music guys who control, who use this. I think they use a serial port to do MIDI communication with synthesizers to synchronize them. Actually, the Analog Pocket comes with one of these music tools preloaded, and they also sent me a MIDI adapter cable, which I didn't try yet. But I think it's only for synchronization, not directly to control things. But it's a serial port that you can freely use, and keyboard and mouse is nothing with a high bandwidth. It should be not too hard to use them through the link port. Someone mentions that actually studying computer engineering gave enough skills to build his own Game Boy flash card. So maybe I underestimated the amount of coding that you learn as computer... I underestimated the amount of electronics you learn when doing computer engineering. I think it probably, maybe this guy can answer it in the chat. This also depends, I think, on what you focus on. You probably have different focuses that you can choose from in your studies, and maybe the electronics part was in there. There's someone in the chat who probably can answer this for anyone who's interested. Do you have any other projects in the works or in your mind? I have few ideas, but nothing too, nothing too that has shaped so far that I would really say, oh, that's something I would want to do. I have to admit, I feel a little bit pressured that the next thing should be a little bit more exciting than this boring video I have on my channel on how I automated my garage door. So because I even would do this differently today. So, but I have a few ideas. I'm not sure. I have to admit, the next few months I probably have to do some other things. There are a few projects that I will not publish that I have to tend to just at home. Things about home automation that broke down during this Game Boy thing, which I have to fix first, which is not worth doing a video. Stuff like this. A few things from work that I want to work on in the evening where I want to catch up. Not because I didn't do this in the daytime, but as I mentioned before, I enjoy my work and there are a few things I want to catch up with, even though it's more time than I would have to invest in the job, and there are a few things I want to do first, but I don't have a definite answer of what would be the next thing yet, so sorry. Okay, we had this one. How many hours did I spend? We had this one earlier. Are you considering doing a 4G cartridge? I don't think so. I haven't seen which kind of modules there are available, but I think if there is a simple module for anyone to use 4G, it would not be that much different. I think so. Don't know. But the interesting part was not getting Wi-Fi to work, because that comes with the ESP, but the communication with the Game Boy and using Game Boy code. And for G cartridge, this part wouldn't be that much different, I think. So I don't think so. Also, it doesn't get much more practical from this. So it's not practical with Wi-Fi, and it's not more practical if you try to get out your Game Boy on a bus or on a train or something like this, and try to stream a game from your PC at home through a 4G network or something like this. I mean, it would be impressive, and you would draw some attention if you suddenly seem to be playing GTA on your Game Boy just by itself. But if you want to pull this stunt, you can also use a hotspot on your phone to get Wi-Fi while you're out there with your Game Boy. But it's not too practical anyway. Have you seen the Tomb Raider port of for the Game Boy Advance? Yeah, that's one of the projects I mentioned that I had the impression that there's still a lot of development going on. I'm not sure the earlier question would also consider Game Boy Advance as Game Boy development, or if this is too new. This is always a matter of perspective for anyone. For me, Game Boy Advance is a modern device that I didn't have as a child. I saw the headlines. I didn't really look into it. Because I have to admit, usually, at least through the last few weeks, whenever I had time to look into something on my phone or into news feeds, I was mostly looking at all the, I think, 1,000 comments. I'm not sure how many comments I got for the videos. I was quite occupied with catching up with the stuff that was said and written about my things, and trying to answer some of the comments. I early gave up answering all of them early because I couldn't do it, but I didn't read much of the other stories, but I've seen the headline. I should look into it too, yeah. That's an interesting question. What do you think about procedural generation of tiles? Would something like Krieger 96 Ego Shooter would be possible? For those who don't know this, Krieger 96, okay, I didn't know about the number behind this. That's a very impressive demo of an Ego Shooter that's written in 100 kilobytes, something like this. I should look this up before I say something wrong. And they're able to do this. That's the name. 96 kilobytes is the size of the Ego Shooter. So just 96 kilobytes. So in this second video, I measured the amount of data in Tetris cartridges. Actually, sorry, I'm not even sure if I got the calculation right, because I used the size of a compressed ROM there. Sorry, so I think it's a little bit fewer. But the minimal cartridge size on Game Boy was 32 kilobytes. So that's a really small cartridge, like Tetris. And just in 96, so in 3 Tetris cartridges, they were able to build an ego shooter. Yeah, search for this, watch a video about this. It's impressive to do this in 96 kilobytes. And the question is if something like this would be possible with procedural generation of tiles. I'm not sure if Krieger 96 would be possible. This probably also depends on the type of cartridge that you allow, because the cartridge can have very different sizes thanks to the memory bank controllers. And I mean, in theory, they can hold gigabytes if you allow flash cartridges. But I think you're mostly thinking about the original ones that Nintendo used. I'm not sure if you couldn't pull something like this ego shooter, because it's not that easy to. You do not have much computation power to do these live animations of something 3D. But a cartridge that doesn't use that much memory and that you turn on and then pre-calculates a bunch of tiles and unpacks them and shows much more than than what you would expect from the original size. I think that should be possible, but you have to allow for a cartridge that can store the results of unpacking. So it's probably not that impressive in the end, because on the original cartridge you do not. In the end, you will only have the memory, the RAM on the Game Boy, because one aspect of Krieger 96 is that it unloads into the RAM of a much more modern computer than you would expect for 96 kilobytes and unpacks to a tremendous size. And you do not have that much RAM on the Game Boy, so you have to allow for a cartridge that brings the memory into which you unpack it. And then, of course, it's less impressive, because for an outsider who doesn't understand what's going on inside, you're saying, okay, there's this cartridge, it has, not sure, 100 megabytes of RAM, but ignore that. The actual game in here is just 96 kilobytes, but it's unpacking into the RAM, and you're not seeing any of this. So it's not like you have a file of 96 kilobytes, but you have a cartridge that has actually more memory. So maybe that's breaking this a little bit. Yeah, but I think the principle of unpacking data into procedurally generated tiles shouldn't be any problem at all. It's just probably not practical for most applications on the Game Boy, because you cannot preload that much unless you have a cartridge that does this, and then you can also just pack it with more memory in the first place. But yeah, anyone who likes this type of stuff, Krieger 96, if you haven't heard about it, it's worth looking up. It's really impressive what you can do if you write very clever code that then unfolds into much more data and use this. Would a telephone cartridge be possible? A smart cartridge? Depends on what you want to have there. It depends on what part of a phone you want to copy. I mean, we can stream video to it. You would, if you want to actually do a phone call, you would have to include a microphone into the cartridge. Then you probably will bypass the Game Boy, so you would probably talk into the ESP directly, because you do not want to process actual waveforms on the processor of the CPU anyways. And to output it, you would probably use the audio pin that I dismissed earlier. So in the end, the Game Boy would probably just be a fancy speaker for your phone, which is implemented in the cartridge. So I think it's not that interesting, unless you think of other functions of the phone as a smart cartridge. How much does the cartridge affect battery life? Badly. So it's drawing so much power. I do not have a number on how long it runs, but another problem is that the cartridge stops running as soon as the batteries are drained just a little bit. So I cannot even run it on rechargeable batteries. I would love to, but it's not as easy as saying that they have a lower voltage, because they have a lower voltage for a reason. That has to do with the inner resistance. I'm not sure what the English term for this is, but the type that the resistance inside the battery works is a little bit different, which is the reason why they get away with lower voltage, or actually should have lower voltage. So it's not as easy as saying they have lower voltage and that's the reason they don't work. But I didn't get it to work with any rechargeable battery, and with these alkaline batteries, they usually start at around 1.6 volts, and if they drop down to 1.45, so they are not really empty, it's, let's say, half empty, the cartridge stops working. It's just the power isn't stable enough anymore. So I have some spare batteries over there in case I would be showing more demos. So it's really bad. Yeah, do not expect to use it too long. But on the other hand, also sometimes there's still some timing issue or something, some reason that it just glitches out. So at the beginning when I showed more, that you saw my face while I was talking, and that the GTA was kept running while I was talking, I was actually quite surprised that it was that stable. So it's nothing you can really do over a long time. How you're encoding color frames for the Game Boy Color? Is there something more there? Because we had this before. Okay, so it's mostly the question we had before. So if you want to know how I do it, it's just a quick solution because I didn't have much time to develop it. It's earlier in the video. I hope, as I said before, that the video stays up. I was quite confident before I started because otherwise I would have recorded it. If you want to look into these tricks with changing the palettes while streaming, I'm not sure if it's in there, but someone drew my attention to a Game Boy video player running on the Game Boy Color, and it looked quite good. I'm not sure if this does do this type of trick, but maybe it's worth looking into this project. And someone in the comments mentioned there's another project that demos getting 2000 colors out to the Game Boy Color. I don't have a name, I didn't find it, but or didn't even search for it, but maybe there are projects out there that might help with this. I'm not swapping the colors in H blank. I'm swapping them in V blank. So I've got these 8 color palettes for each video frame. Because I use 2 frames to transfer all the tile data, and I switch the color palette between those, and I also make sure that I transfer the tile data for the first frame behind the refresh of the lines, so you do not see the new data until the color has been switched. And then when there's the next scan, I run ahead of the tiles for the other one, so each frame actually uses a fresh set of palettes, but only these 8 palettes. I didn't do the other trick. It's tempting to still improve on this because I actually want to try this, but it's not in my project yet. I'm not sure if it's coming. Okay, do you think cluster computing would be possible? Double the computation or something in this direction? So I'm not sure which direction you're thinking. If you want to use the processing power of the Game Boy for something else, it's not worth the power or the cost of a Game Boy. So there's really not much computation power in there. For the other direction, not sure for what, but double the computation or something in this direction. I'm not entirely sure if I interpret your question correctly, but using the Game Boy for cloud computing, for cluster computing, it's probably not worth it. It uses much more power compared to the output, so that's probably not worth it, and they're not that cheap per CPU cycle that would be worth it. I've seen, again from headlines, I haven't looked into it, someone who was trying to mine bitcoins on the Game Boy. I think this is, just from the headline, you realize that this isn't a good idea, but not sure if we got it to work, but maybe that goes in this direction. Would you make a video layer where you stream a Game Boy game using this cartridge? Okay, no, I see what you meant. Yeah, we had this question earlier. So I think streaming a Game Boy game just from a PC should be no problem. Getting a Game Boy emulator into the cartridge and using this technique to show the result on the screen might be possible with something like Raspberry Pi Pico or the RP2040. So but I do not plan on doing this at least anytime soon. I so find this tempting, but Okay, let's. Okay, I have to read it again, but put it on because VFox was mentioned. Are there any other handheld consumer products you could theorize using effectively for different physics experiments using internal sensors such as how VFox uses your phone? Okay. So, that's actually a VFox question, but sure, why not? There are some... So VFox has support for Bluetooth Low Energy interface. So sorry for all, just that question, I put it on the screen now, I answer it. So there are a few devices that you can use with VFox on your phone. Not too many, but this interface is very powerful. So pretty much anything Bluetooth low energy can be used with VFox. So for example, a computer mouse is not the best example. That's not running that smoothly, but there are quite some options that that can be used. When developing VFox for smartphone, not for other devices, mostly because those are the devices that are very available pretty much around the world. I mean, even in countries where you think they have bad infrastructure they do not have much available for teaching, they usually still have phones, old phones, but they have smartphones. And so that's the interesting thing about VFox, that it's a device that every student has. So that's why we're going for this. But VFox can at least use some external sensors and some things like heartbeat trackers and I cannot come up with a good example for something you might have at home right now, but there are some Bluetooth devices that can work with VFox. I don't want to make this stream about VFox. So yeah. Does the script support Unicode? You're thinking about the Wikipedia example or the serial or the Telnet example, I think. There are two reasons why the answer is no, but one reason is a simple one, because I'm using the Game Boy Development Kit 2020, and the tile set for characters is very limited because it only has these tiles available in the Game Boy, and they do not have any Unicode characters. They barely have the ASCII characters, so the 7-bit ones. Which is quite lucky for me, because there's actually an error in the code that's still on GitHub right now, because I do not use the 8-bit anyway. But there's an error in this in the code for the text-based examples, so the Wikipedia example and the Telnet example. I think I call it serial example, because the what I did in these codes is I said, okay, for setting up the GPIO pins, I can use just the commands from Arduino. So there's this set mode or set pin mode command where you can say, okay, this GPIO pin should be an input, and you want to enable a pull-up resistor on there. Oh, my light is just going out because it's running out of energy. Yeah, okay, I have to figure out a way if we want to show something on Game Boy later. I used the Arduino code for this, and what I didn't realize is that this does more than just set the GPIO direction, but it also enabled it disabled the driver for the pin, which is not relevant for an input pin. I think they do this just in case something goes wrong, because it's better practice or something like this. I don't know why they do this. But what it does is, when I then use just the register to directly switch to an output, when the Game Boy wants to read data from the ESP, the driver, the bit in the register was still set that the driver is not actively driving up. So it's basically an open drain mode. So yeah, I think I have to explain this to all those who don't know what this is. So in electronics, I think I try to draw something again. So once again, let's check if you can see this. Yeah, you can see this. Let's get a new page. So, can I even draw this? No, I think I will embarrass myself if I try to do the right drawing. I will try. So usually you have got your Arduino or microcontroller or something like this, and you've got your GPIO pin. And if you use this as an output, you are used to setting it either to high or to low, and then it goes to either 5 volt or 0 volt or something like this. So your typical design would be, in theory, you could simply, you probably should not always do this, but let's do a very simple example. You use an old light bulb, because I don't want to discuss resistors for an LED or something like this, and attach this to ground. And you can simply drive it high, so then you have got like plus 3.3 volt on a new one, and this one would emit light, yeah. Or you can set it to low, and this goes to ground, And yeah, there's no voltage drop across the light bulb and nothing's happening. And open drain mode means that it does not actively drive it to 3.3 volt, but what instead you have to do is you have to, yeah, it's not a feasible thing for a light bulb, so sorry, this example is bad, but the idea is that you attach a big resistor, something like, let's say 10 kilo ohms, so it's so-called pull-up resistor, to 5 volt. So light bulb, again, light bulb wouldn't work with this, the resistor would be much too high. And then if you set the GPIO pin too high, it doesn't do anything. But if you set it too low, then it actively drives it low. And because this resistor is so high and this effectively drives it to ground, then you can put it down to ground. And if you turn it off, it goes up to 5 volt or 3.3 volt or whatever you are doing. It should be, if the microcontroller is 3.3 volt, it should be 3.3 volt. This is actually a good idea for many cases where you want to avoid short circuits. So you might have a situation where, yeah, like in the Game Boy, you have multiple devices on a bus and you are afraid that there could be a short circuit if one thing, so this would be a data pin and not a light bulb. As I said, this is a bad idea. So this would be some output for some data bus, and you've got another device on the same bus, and if one drives it to 3.3 volt and the other one to ground, then you have a short circuit. And with this open drain design, this cannot happen. But the problem is, with my Game Boy design, I actually have already some pull-up and some pull-down resistors connected to it. Can I get the schematics here? Just a second. I should have expected to show those. So, where is it? There it is. PCB, Wi-Fi card, and yeah, there's the PCB. No, not the PCB design. The schematic. We want to have the schematic. There it is. Let's go onto this screen again, because it has a much more sane resolution than the other screens. It's the main reason why I'm looking down here when I'm doing this, because I have this on the graphic tablet at a reasonable resolution. What you see here is that, so this is the ESP, these are the GPIO ports, and on most of these I have actually a pull-up resistor, like this one, or this one goes to 3.3 volt. But this 8th pin, so this is D7, so these are the digital pins that communicate with the Game Boy. So we've got D0, D1, 2, 3, 4, 5, 6, and the 8th one is D7. And this one actually has a pull-down resistor. This is just because, I'm not sure, it has a function for the ESP. Either it tells it to start up in the, not in programmable, but in run mode, something like this. So the ESP needs certain resistors to start up properly. And this is one of them. And now if you go into open drain mode, it's already pulling it to ground, but there's no resistor pulling it up to 3.3 volt. And in the original video, in the original blog post, I think, somewhere I mentioned that I was confused that I had to enable the internal pull-ups to make it work. So for example, so on the ESP itself, there are also pull-up resistors that can be activated internally. So I add another pull-up resistor to this one, going up to 3.3 volt, but this is only like 6 kilo ohms. And if you look at the result, then if you set this pin to too high, it doesn't go too high because it's in open drain mode. It doesn't actively drive it up, but instead you get some voltage between 3.3 volt and ground, because there's a resistor to 3.3 volts internally and this pull down resistor of 12 kilo ohms to ground, and you do not really reach the voltage level that you need. And that's because I did this mistake of using the Arduino setup function to set up the pin mode, and then only using the registers to switch between them. And so the serial, so to come back to the original question, sorry that this was such a long answer. So in the original code for these, I had this mistake that they are running in open drain mode, which works for pin 1 to 7, or 0 to 6, if you want to count to 0, with the internal resistors, but it doesn't work on D7, which is the 8th pin, because it only has a pull-down resistor, which counters the internal pull-up resistor. So actually in these examples, I only have 7 bits to transfer, which I never noticed because the Game Boy development kit only has a 7-bit character set, so there are not these Unicode characters in there. Actually, Unicode goes beyond this. So yeah, you only had classical ASCII code in there. So, and I only noticed this when I did the video streaming, because suddenly I had the same line in each tile because the 8th bit wasn't working. And then I finally figured out why I had to use the internal pull-up resistors when I looked onto the communication with my oscilloscope and figured out that this 8 pin goes to some strange voltage between those. And then I realized, okay, I have to set up the GPIO pins not with the Arduino function, but by writing the registers myself and avoid setting this one bit that messes it up and brings it into open drain mode. I hope I have somehow explained it to it's a strange mix of explaining it in my own words because I don't have the right words because I'm not an electrical engineer, explaining it to those who probably have never heard about this open drain mode, and I hope I got the mixture right for most of you. Sorry. Okay, so yeah, that should answer this. Not an actual question, but more of an idea I have here, but the question's missing, sorry. How do we go on? Okay, how do you go on about project like this? Do you have a specific structure that you work along, similar like scientific work? Not really. I know a few things that I usually skip, which I shouldn't skip, because for the Game Boy cartridge, I never tried it on a breadboard. That's usually a good idea before manufacturing actual PCB. I could have avoided many mistakes on the first PCB. On the other hand, some of the mistakes there I would have done anyway, so I would have to have a second revision anyway. But no, there's no specific structure. I would also consider some of the purely software things as projects, and they're quite different. I mean, the last video with a long pause of 6 or 7 months before I did the Game Boy stuff was about a plugin for Blender, which is quite a different project. So I don't have a specific structure for these. Maybe I should have, but I don't. Here's the rest of the other question. Okay, not actually a question, but more of an idea I have, using the Wi-Fi capability to directly link games together like Pokemon instead of using a link cable. The problem with these projects, so first of all, you would have to emulate Pokemon on the cartridge itself because you cannot cramp in another cartridge while this one is in there, which is already not possible on this hardware design, as I mentioned earlier. The other thing is principal problem also for these link cable. You were asking about link cable. There are projects that use the link port for Wi-Fi communication that are also quite interesting. I linked 2 of them. I think those are 2 I found in the first blog post. So if you look at the blog post of the Wi-Fi cartridge itself, there are 2 links to projects that try to do Wi-Fi for the link port, which in a certain sense is easier because it's just a serial communication, so it's quite easy to catch the communication from there and then push it to some Wi-Fi module and catch it at the other end and send it back. But the problem if you want to do this to existing games is that the existing games on the Game Boy do not expect network latency. When they designed Pokemon, they never thought about that the communication from one Game Boy to the next one could take, in the end it's just milliseconds, but they expect that the Game Boy at the other end is right there at the end of the cable. So even though it's not a fast communication, they do not expect any latency on this communication. And I think I've read that this is a problem for most of these projects. There is one project that's very impressive that does multiplayer Tetris via a server with the original cartridges. This is a really exciting one, so I think that's one of the ones I linked there. But I think that's because Tetris is quite forgiving in how fast they want to have an answer from the other Game Boy. Not sure about this. And the other example, they simply write their own game to do this because of this problem. So for existing games, it's not that easy to convince them to deal with the way communication works nowadays through a network like Wi-Fi and the internet. So that's the main issue there if you want to work with existing games. For new homebrew games, we could do a lot with this Wi-Fi thing if it was more stable. So I do not recommend that someone builds a Game Boy game around this unless you find someone who knows how to solve the power problem on these. Recommend okay, now we do this kind of thing. Recommend a book, a movie, and a TV show. Okay. I wasn't prepared for this kind of question, but I will go along. So a book. I think if you ask me any time in life, I would recommend The Hitchhiker's Guide to the Galaxy, but that's a too simple answer, I think. The last book, I think, yeah, geeks around you will know this, but the thing I really recommend is We Are Legion, We Are Bob. So the Bobbyverse books by Dennis E. Taylor. If you maybe I'm telling you recommending a book that everyone knows, but this is very cool book, written from the perspective of a Van Neumann probe. So a guy who becomes a space probe and starts to explore the universe by replicating himself. It's very geeky, it's very fun to read, and well written. I would recommend this one. A movie. Let's go with TV show first. The thing I would recommend as just a recent thing, I really enjoyed the Loki series, but that's the current stuff, the easy one. The not obscure one amongst geeks or nerds, or not sure how to call myself and people like me, but maybe old enough that some of you don't know it, is of course Firefly. So this science fiction series by Joss Whedon, I'm not sure how to pronounce him, which only lasted one season and was discontinued before this, but it's a great series. I can TV show. I can really recommend this. Movie. Why is movie so hard for me? Because I think I don't want to go with one of the default stuff. I cannot just pass on a movie, can I? I mean, yeah, the thing I love is of course Back to the Future. So here you go, yeah. But something more obscure. I think I have to pass on something more specific. Back to the Future is also an easy answer, I know, but I cannot really think of. I watched mostly mainstream stuff recently, so I could tell you which movie I like most of from the Marvel universe, but that's not a better answer than Back to the Future. So I think I stick with Back to the Future right now. I don't want to think about it for 5 minutes now. So yeah, hope this is a good answer. Okay, that's not a question, but a recommendation. Sounds like interesting for some of you then. If you're looking for Game Boy camera stuff, check HDR's project for a flash camera card on JIT. The Game Boy camera has a custom chip inside, which writes to RAM in parallel with the Game Boy itself. Okay, that's so, yeah. I think I will have to watch this video myself later, at least the chat. So there's some recommendation I want to check out later. Sounds interesting. So yeah, happy to share it with the rest of the audience. Yeah, okay, that's something we more or less had already. Question if I think it's possible to use the Wi-Fi card to load ROMs from network attached storage, or maybe anything else. I mean, it could send it to there. In principle, it's definitely possible. I mean, there are these kinds of cartridges that can run games from a flash drive, but it's not possible with this cartridge because I cannot write to the... Yeah, mostly answered this something like this earlier. Problem is I cannot write to the EEPROM, and even if I could only run the 32 kilobyte games because you have to emulate the memory bank. What's the name? I got it right before. The chip that switches between different memory banks. Yeah. It's really annoying me now that I then cannot come up with the name again because I had it earlier. So yeah, you have to do more than just have a memory chip in there, but there are cartridges that already provide this from flash memory, and like the EverDrive, I think, and adding a Wi-Fi cartridge would be possible. I don't think that anyone will do this commercially because I think right now you can pretty much put the entire Game Boy collection on a flash drive. So I don't think it's that relevant to load them through a Wi-Fi connection. You can just build a cartridge with enough memory, I think. So Memory bank controller, thanks, yeah. MBC was the name I had in my mind, but I didn't remember what C stands for. Memory bank controller is the chip I was thinking about, thanks, yeah. Okay, so yeah, this one. I'm seeing the end of the question list, so not that I want to get... I'm eager to close this, but we're going on for 3 hours now, and I think it's okay to come to an end. Oh yeah, do you have any plans on integrating your Game Boy to your home automation system? That was one of the plans I had before I did the video streaming. I think now it's not impressive anymore, because yeah, it would look similar to the Wikipedia example. I think most development time would be put into getting a nice menu onto the Game Boy, which I do not have that much experience with. I mean, I streamed a video there, but and I wrote this in assembly. But in the end, this is just a long list of memory copies, which I have the right order and right timing. So I would mostly spend time on writing the menu for the Game Boy. On the Arduino end, there are nice MQTT libraries for Arduino, which I could just use, which I used in other projects already. So for example, in my channel, there's this smart doorbell example where I connect via MQTT, and from there I can pretty much control anything in my home because I have everything on MQTT, available via MQTT through OpenHub. Unfortunately, I never went with Home Assistant. By now, I think I should have gone with that, but OpenHub has been set up entirely. And so this part would be easy, but it would mostly be writing a menu for the Game Boy, and I think it wouldn't be too impressive anymore after the video streaming thing. So I think I will drop this plan, but it shouldn't be too hard if you can write the stuff on the Game Boy. Okay, this question is probably more for those people who have spent more time with Game Boy modding. If it's possible to upgrade a Game Boy, like better CPU, more RAM. So my first thought would be, why would you do this? Because the problem is, you wouldn't. If it's a Game Boy, you would only run Game Boy cartridges in there, and a faster CPU doesn't help, especially because these systems depended a lot of the right timing of everything. So a faster CPU would probably break all existing games, and yeah, if you could write a game for your modded Game Boy, probably, I'm not sure. Maybe someone has tried something, has done something like this, but you have to write games specifically for this modded Game Boy, it's probably doesn't probably help anything. Yeah, I think that's the answer to this. Maybe some of you who spend much more time with this retro modding and hacking stuff knows a project that might fit this answer, but it's I think it wouldn't be really helpful for anything. Yeah, the question about if I thought about using ESP32, we had this, so sorry I referred to an earlier thing. Again, I hope this video stays up and I can add markers for the chapters where certain questions are answered. Where are you from? Yeah, thanks to my accent, I think everyone knows I'm from Germany. More precisely, I'm from the west of Germany. I think I can even narrow it down to say that I'm from Viersen, which is a city near Düsseldorf, is probably what most of you might know if you're from farther away. And I work in Aachen, so the RWTH Aachen University, which is, if you go south from Düsseldorf, it's roughly on the same latitude as Cologne, I would describe it. Hope this answers the question. What's your Tetris Highscore? I cannot give you the number, but when I got the Analog Pocket, I tried if I can still get the rocket. But I only tried mode B, which is the fast way to get the rocket, and I immediately got the small rocket. I think you can get bigger rockets in mode B if you get a higher score, but I haven't tried it. I'm not sure. And as a kid, I definitely got the biggest rocket on mode A2, but I haven't tried it again because that's yeah, take some time, and I think I would be disappointed that my Tetris skills have been lost. But as a child, so that's one of the things the memories I have on the Game Boy. When I went on vacation with my parents, that was when I was allowed to play Game Boy for the entire road trip or the entire drive to the destination. So when we went to Italy, I had many hours of time to play on the Game Boy, and that's mostly the time when I was allowed to spend so much time on the Game Boy. And yeah, Tetris was of course something I played a lot, and I managed to get a big rocket at that time. By the way, that's also one of the most memories I have about this screen. Many people mentioned after my first video where I mentioned that I don't remember the screen being that bad. Actually, I remember the screen being bad. It's just part of the story in the video. But you correctly mentioned that the screens degrade. I didn't know that they degrade that badly. So yeah, thanks for the info. But the thing I most remember is that not having a backlight was a big issue, because when you're just in the back seat while your parents are driving, and you have to educate your parents to warn you about tunnels, because otherwise you lose your game. So yeah, that's my memories about the Game Boy and Tetris. Okay. Do you think it might one day be possible to use trained AI to get your input video to GBC converter to display input video as accurately as possible with the max amount of color allowed on the GBC? I'm on the Game Boy Color. I'm not sure if training AI would be the best path going there, because yeah, I do not see this optimization feedback for this. I'm not sure how you would do this with AI. I think that the first step compared to what I do is you can improve with conventional algorithms quite a lot, and there are nice ways to calculate the color palettes. That's probably better than what I'm doing right now. I'm quite limited because I just use FFmpeg instead of coming up with my own algorithm, and cannot tell FFmpeg about the limitations there. So there is much more possible. And I think before using AI, actually brute forcing it with these few pixels might be an option. But yeah, I don't see AI in this right now. But I think there is a lot of potential in improving this, because it just gave it a quick shot in a few evenings. So between getting this Game Boy and having the stream today, so it can be much better. Oh, I just see something in comment which sounds interesting. Okay, no, but that's no. Okay, I shouldn't read the chat right now in parallel. Any chance of using a camera and streaming it to the Game Boy? Yeah, you probably missed the beginning of the stream, so if it hopefully stays up, jump to the beginning. No, I don't think I have a good answer to this. Is there a place you'd recommend starting to learn circuit design? I'm a software engineer wanting to get into hardware. Digital circuits are fine, but they aren't pure digital. No, I don't have a good recommendation. At the first thought you meant PCB design, but I mostly just went with trial and error there. But my path there was through a few things I already was interested in as a kid. Then these very basic circuits that you learn as part of becoming a physicist, a physics education. And then I learned more and more through projects, but it's not a simple, kind of tutorials that I could recommend. Sorry, that's not how I learned this, so I do not have a good recommendation. But I think there are probably some nice tutorials out there. Okay, so I've got 5 more questions at the moment. Oh, I didn't hit the refresh button in a while, did I? Oh no, it should. I think my script should show them anyway. Okay, so I also caught up to questions from 10 minutes ago, so we are almost through. So if I understand your explanation about Pokemon linking right, a Game Boy via link cable upload and download speed of almost zero, but also a ping of nearly zero. It's hard to say it in these terms. The thing is that when I say network latency, it's not just the ping, but also the problem that your game is lost once if you have a problem if just one packet is lost, depending on the game. So for a proper network-enabled game, you expect that maybe something that goes wrong in communication, and you can just ask again for what you expect in return. I do not think that a Game Boy developer thought about the possibility that a packet could get lost. And also, the link port is not really fast, but a millisecond is much more than you would expect on this. So this is just very different time scales. I'm not entirely sure how most developers program for the for this link port, but since the Game Boy doesn't do much parallelization, I'm not sure. Maybe someone who did the Game Boy development could answer this. Who does more Game Boy development? I think there's an interrupt to react on something that's incoming, but I do not really think that you do much parallel communication, even if you're talking to the link port. I think you simply send something there and expect an answer right away. If you code anything for network, you usually have a separate thread for this, so you send a request onto the network and you deal with it whenever you get the answer, and that's already something I think that Game Boy games would not do, and which is not necessary on the link port. But even if you say that, if you get the impression that your internet gaming is quite fast, and you're thinking of ping that matters for gamers who playing ego shooters or something like this, it's still a different scale even for the slow link port. So there's a very direct communication. You can think of it as really connecting both Game Boys together. I mean, literally, they're just connected by a very short piece of wire. It's something quite different. Also, how packets are handled and what happens if a packet is dropped. So, there are some problems with this, but it really depends on the game. So some games just expect an occasional update from the other game, like in this Tetris example, where you just get a marker on how high your partner is, and you get just a notification if he has won or lost. So in this case, it shouldn't be that much of a problem, which is why you find examples for this. So I cannot really say what Pokemon does in this case. So yeah. New revision, we had this. I think I will rest this project after today for a while. Can you show us GTA 5 on the Game Boy Color? That was also in the beginning of the video. Just go back to the beginning. Again, I really hope it stays online. But I think so. How do we find the time for such expensive projects time-wise besides work and other commitments? I haven't played my PlayStation properly in quite a while, so you have to you have to really manage your time. And it took me months in total time, not in actual work time, but I only get to work on this in the evening when my kids are asleep, and because during the day I have to work, and when my kids are awake and I'm not working, it's family time, and I don't want to miss this. So also that's what eats most of the weekend. So as I said at the beginning, this live stream today is only possible because today my son is sleeping over at my parents, so his grandparents, and so my wife can look after the younger one, and I get some time off to do this here. But it's a long stream of evenings that allowed me to do this project, and this is why I have to excuse you if you subscribe to my channel. I'm very happy about this, but it will be probably a few months before you see the next video on whatever project I will do eventually. So Have you tried to do the new the Wi-Fi cut on a Game Boy Advance? Sorry, I don't have a Game Boy Advance. I just bought the Game Boy Color because people asked for it. So sorry, no, I don't know if it works. But we had this earlier. Yeah, that's also something we more or less had. If the EEPROM could be replaced with an external RAM chip, and Game Boy code could be loaded in and out of RAM by the ESP, I think it's possible. Someone also mentioned that I could be able to hold off booting of the Game Boy until I'm ready by using the reset pin, which I also did not connect on my cartridge. So I think that should be possible to do. Problem is, if you're thinking, again, because we had these questions, if you're thinking about loading any ROM onto this RAM chip and running it from the Game Boy then, we had this question a few times. This only works for the very small cartridges with 32 kilobytes, like Tetris. Otherwise, you have to think about a way to emulate the memory bank controller. Now I remember the name. Because it's not just hooking up memory to the Game Boy cartridge if you have more than 32 kilobytes. Yeah. Oh, now each time I dismiss one question, a new one pops up. Okay, yeah, someone mentions that you are able to scrub back to watch the beginning of the live stream. The only thing I was worried about at some point, but I think these worries are not justified, is that when I finally hit the end stream button, that would be gone, but I think it stays up. I'm quite sure. I've seen many live streams with actually the chat recorded after the live stream was gone, and I did not disable this feature, so I also think it stays up here. Thanks. And right now, this is the last question, so if you want to push something in there, I think we're through soon, because I'm also running out of things to say if you don't have any more questions, because I think I've said pretty much everything. Could forcing the PlayStation render at 160 by 144 pixels instead of its native resolution improve the accuracy of the output video on the Game Boy Color? No, doing something to the PlayStation doesn't really come into this. Okay, you saw that it was, maybe you saw at the beginning that it was jittering a little bit, so I did not really achieve the 30 frames per second, and I think that's because of the screen grabber from FFmpeg. So in this regard, maybe, you cannot really tell the PlayStation to play GTA in 160 by 144 pixels, but the video stream from the PlayStation actually already is in 720p, I think. And I scaled it up to the full resolution of my laptop, which is 1920 by 1200, which is why you get some letterboxing at the edges, because I again forgot to cut these away, because the PlayStation game is 16 by 9 aspect ratio, and my laptop is 16 by 10, so you get these small black bars at the top, at the bottom. And maybe if I run it just in window, or even resize the window, the grabber from FFmpeg could have done better, and without dropped frames and at actual 30 frames per second, maybe. But for all other parts, my Python script only comes in after FFmpeg downsized it to 160 by 144 pixels, and there's nothing that would help before this part of the pipeline, I think. There are 4 new questions. So when I asked you about it, you pushed in a few new ones. Okay, so this one was already asked. What was the biggest problem you had to overcome for this project? I didn't really have a good answer, so I'm not even sure what I answered when the question was there earlier. I think it was mostly hardware-specific stuff, because the electronics part is not the stuff where I'm most comfortable with, or about which I knew most when I started the project. Code is patient, so you can just change the code anytime. But when you ordered a PCB, you have to make do with what you got there. By the way, one problem that I faced, you might see. Oops, it's the other way around. I should probably just look at it if I want to point at it. This part here is some missing traces on the PCB, which I had to fix when soldering the thing. Yeah, so that's because when I ordered it from Eisler, they do not use Gerber files, so the actual layout of the PCB, but they directly take keycut files, and their keycut renderer has a bug in there, which they told me it was fixed by now, but yeah, this PCB missed some traces over here, which I had to fix in post. So stuff like this. I think most time was designing the PCB, learning about some electronic parts that I didn't know about before, and I learned so much later. So to figure out how to do this, because in the end you do not have one shot, but each shot takes a few weeks until you get your PCBs, and it costs some money. So that was, I think, where I at least spent the most time, and I had to learn the most, and we want to make sure to get it right. Because if you don't get it right with code, you just change the code. But with PCB, that's a little bit more work. Thoughts on the Intellivision Amico? I think I have to put this into Google to answer this question. Let me Google that. Oh, what's that? Okay, looks like something I have to. I never heard it, and I've never seen this type of device. I think it goes onto the list. I think of things I have to look into after the stream. So I never heard the name, and I've never seen this thing. Looks fancy, interesting. But it's okay. It's new console that's announced. Okay, haven't heard of it so far. Sorry. What were your favorite games on the Game Boy? Actually, that's also something that annoys me a little bit. I mentioned that I just found the Game Boy on my parents' attic, and I remember a few games that weren't there. I'm not sure if those were the games of my brother in the first place, and he sold them with his Game Boy, or if I just didn't find them yet. So definitely my most favorite game, and that doesn't surprise too many of you probably, is Link's Awakening, Zelda. I never played Pokemon. I'm not sure if it was too late or if I didn't get what it is when it came out. But I actually started playing it after playing some Pokemon Go. So and I found it quite nice, but that's not from my childhood. So from my childhood, this is definitely my favorite one. I have fond memories of Nemesis. Sideways shoot 'em up. Shoot 'em up, is that right? Sideways scrolling shooter with a spaceship, but I think that's also quite a known game. Mario Land 2 is also a very nice one that I enjoyed a lot, but that's definitely a cartridge that my brother owned and that he sold with his Game Boy. So I think these are the three that come to mind immediately, which I really enjoyed. Yeah, I think 3 are enough. How are you doing? I'm doing great because I've got a nice audience to talk to. It's always fun. Okay, so thanks for the interesting stream. Okay, so I think we're getting to close. Okay, more what is it called? I don't. Among Us, I didn't get the name, so a few Among Us memes. I have to admit there were quite a few below the video. I did not get all of them. I've played Among Us, but I do not really. I only played with a few friends who do not use the enthusiast speech, so sorry. I think I answered this one for to what extent is my work related to these projects. It seems like you have a lot of knowledge that would be difficult to acquire only as a hobby. We had a similar question before. I would refer to this, but I have a little addition to this. Actually, I'm using at my work right now more knowledge I acquired as a hobby than I acquired during study. That's not entirely true because it's very physics related. I couldn't do what I do as a job if I wasn't a physicist, because I really need this knowledge there. But main thing that is important about my work is coding and developing apps in this context. And that's something I never learned during studying, but from my hobbies. So it's actually, to a certain extent, it's the other way around, or at least I found a niche where both match each other very well. Okay. Okay, with more Among Us, I think, or at least, is it? Sus is a suspect in Among Us, right? Suspicious? I think it's more Among Us. Okay, so this was the last serious question. So I think it's, oh yeah, the chat is also going with Among Us right now. So I think it's, it was plenty of time, so it's a good point to end this Q&A session. Thanks a lot for watching this. It's actually quite amazing for me to get so much attention for this hobby project. I mean, I gained, so when I published the first video of a Wi-Fi Game Boy cartridge, I had 2,500 subscribers, and now I have about 35,000 or close to 35,000. I've never thought I'd see this, at least not so quickly. If you're wondering, my goal is not to earn money with YouTube. It's nice to get back the money I spent for the oscilloscope for these projects, so I can finance the projects. But that's about it. I'm also quite limited on how much I may earn on site on my main job, so that's not the goal. If you ask me what my goal is I want to have that silver play button, so tell people to subscribe to me, okay? So that's my personal goal, the achievement I want to get from these projects, or from publishing them as videos. So yeah, thanks a lot for the attention. I think that's nothing I could really expect, that I have the chance to talk 3 hours or 3.5 hours to strangers who are just interested in what I have to say. It's really amazing to do this. So yeah, be patient. It will be a while before I post the next project. I think that's it for now for the Game Boy stuff. I might return to retro gaming stuff eventually because I really enjoyed this. But I have no idea what will be next, and it will be a little while. So I hope you are just patient and trust me that it hopefully is something interesting. And before I keep talking for another 5 minutes, thanks for watching, and see you in the next video eventually. Good night.